Welcome to the Clutch Burners Podcast. This is your home for stick shift drag racing, stick shift tech, and more. And tonight we have somebody that knows a little bit about clutches. But right over there in the fancy hat tonight, right there, that's Rich Guido.
And right over there is Mr. Bill Armstrong. And our special guest tonight is
Who is it?
Cale from Black Magic.
Oh yeah. Oh yeah. No, wait. Hi, Cale. But before we jump into this, Rich, what'd you just come back from?
I just did a little drive in the winter again. But this time it was down to do a little dyno session to make sure the car was okay before driving 3,000 miles to Florida. And because the last time I broke I broke the rear end, I broke the transmission, and I also have a new Cale clutch back in it again. So I really wanted to test the transmission because I shocked it pretty good. I had a pretty good look at it, but so laid down some numbers to get me to about an 845, 35, maybe a 35.
And would be just fine.
Yeah, so it made good power. But it was more about it wasn't as much about the number. You always like to see the number. Made 1,485 to the tire at 16 and a half pounds of boost.
At what RPM, Rich?
At 5,600 RPM.
Dude, that's ridiculous.
Yeah, it's a little ridiculous.
Now, for people that don't know you or your car that well, just give us the quick details on the setup.
So it's a 65 GTO. I don't own a truck and trailer, so it gets driven everywhere, like through a snowstorm today to get home. It's 4,000 pounds. It's got a 520 cubic inch Pontiac with a 94 millimeter turbo. And then it's got one of Cale's next gen clutches on it. And I'm not just saying this because I've posted this online many times. It is the best street strip clutch that I've owned. It's so easy to drive. And I think when I went to Florida last year, I think I took like 8 thou off the disc, and that was like 7,500 miles. And I think I made 9 passes down there, and I averaged 8. So I think that's pretty impressive for an 8-second car, or for a 4,000 pound car running 8s.
And it's safe to say you probably have a 4 or 5 foot stack of clutches you have tried in your garage, right?
Yeah. I got a high school, a college education worth of clutches in my garage.
Oh my God, that's amazing. I'm going to silence this phone. All right. Cale, sorry.
One more before. Yeah. So lots of people ask me stuff about, when you're running an adjustable clutch like I do, how does it work on the dyno? What do you got to do? And lots of counterweight. I crank it up for the street. Lots of base pressure, lots of counterweight, and it never missed a beat on the dyno. You just gotta make sure you got enough RPM in it so the counterweights are working. And then I'm by no means the expert on here, but it worked good. No problem putting down 1,400 horsepower with slicks and not roasting the clutch. So, anyways,
that's impressive, buddy. So, Cale, tell us a little bit about yourself. Background, business. Just start talking.
I don't know. Most people try to get me to shut up, but
well, we'll get there. Don't worry.
Right. The biggest thing with me is, pretty much been playing with stick shift cars, obviously, my entire life. And, so it's kind of those things where a lot of people always know that I obviously second generation pro stock, mountain motor side, this, that, and the other. But, as a kid, I wasn't allowed to, might be the right way to say it, to just jump in. It was like, no, you got to do school, got to go to college, you got to, there was all these things. And my dad started down that road and then pretty soon figured out that, that wasn't going to last very long. So, but, obviously I started off in a lot of the small tire back in the old NMRA hot street style days and the Fun Ford Weekend Street Bandit, all motor, small block, 10.5 tire stuff, and kind of gradually played up. What's funny is I was playing with that while I was in college. And then by, I think midway through my junior year, so I was about 22, I decided I needed to go for an Outlaw 10.5 car because at the time, Glidden was the nitrous king and Tim Lynch and Steve Petty were the turbo boys, and pretty much, battling back and forth. And I decided, what the hell, let's let's see if we can do it naturally aspirated. So I went down that path and, built basically a 700 incher on 10.5s with 8 individual. I even went EFI back in '05. I was like, why not? 8 individual throttle bodies and, clutch. And yeah, long story short, 10.5 racing. That thing, what's funny is talking about reason I bring that up, Rich was just talking about it. It was made about 1,465 horsepower. It had to be a wedge steel, long story, but at 2,900 pounds, and that thing could, click 697 O's about everywhere it went. And so, it was a fun little car. But, at my house, it was basically a mortal sin to don't push the clutch pedal in or touch the brakes before the finish line. And, let's say this way, most of my customers are bracket racers, love them to death, but my family, it wasn't really much allowed. But the one thing that always transitions in the clutch world is that when you look at Pro Stock, for example, it's the most consistent heads up class you're going to find. So, you look at it from that perspective. Once you get consistency, then you can start ticking away for more performance. Consistency's got to be first so that you can keep going. And so, it's as much as that is a lot of my background, a lot of other stuff is, there's more to it. So, me getting into the clutch world, I've always liked design and development. I like the numbers. It's a thing where, to me, I was, even in Pro Stock, an idiocracy is saying that I was a budget. I've always been a budget Pro Stock guy. The two words don't go together. However, it just meant you had to think a little harder than the next guy. You had to, when you came home, you poured through that data. You looked at that. You worked that much harder to figure it out. And John Causey taught me as a little kid, you can either race rich or you can race smart. And I can tell you right now, it's physically not possible to do both.
Can I add something?
As soon as this,
I like to race rich. And he's sitting right there next to me.
So wait a minute, I guess that makes you smart.
Yeah.
Yes, Rich is the smart one.
It is interesting how you say that, though. That's one thing I've been really paying attention to lately is guys like Beaterbaum and even AV Boys. Like, those guys are all about grinding through the data, just like you were saying, Cale. Like, it's you got to look at the data, and I think in the stick car world, that's the biggest gap right now for a bunch of us, is to try to be consistent enough to know you're making improvements, because we're, how often are we all over the place?
Oh, that's the funny thing, is a lot of people don't realize why I always bring back Pro Stock stuff. It's because, it's kind of funny, this last year I've kind of got on board and partnered up with, a couple of twin brothers, which is Derek and Reese Miles, or God, I just said it backwards. Derek and Miles Reese, see how I am? But Derek, it's got his first year. Miles is going to be driving, my old car actually here soon. And, they even got his grandpa, their grandpa out playing. And it was kind of funny when we first started out the season, and I kind of went back and I showed them, I'm like, just stacks and stacks and stacks of notes and information and binders. And, it's everything that we did at any point in time, I had it down. I could pull up every run. And, the thing is, it's kind of like, which I won't dive in this right this second, but, one of the things that gets interesting to me when I have tech calls and people call me up and we go through a clutch, options and setups, is two of the biggest things I hit on is two-step switch and a positive pedal stop, setting the air gap. And I regurgitate this over and over and over. And, the thing is, I'm telling them, I'm like, so often it's not even about the base and the counterweight and the launch RPM and the suspension and this, that, and the other. It's got to do everything consistently every time. So when you go up there, if your stuff's not set up to launch, if you set it at 5,200 and you actually look at your data and it comes off at 54, 50, 56, or it bogs and it goes down, that's an inconsistency. We need to be able to go up there and know that if I dial it up 100 or down 200, it's got to do what we tell it to. Otherwise, you're not really tuning. You're kind of guessing. So once again, it all comes back to consistency. And that's where you guys know me well enough. That's why when I get into clutch design and doing development and doing tuning and things, but that's why the clutches, we go into things. And I learn things. As funny as this sounds, when I broke my neck almost 8 years ago, running Pro Stock, there was challenges in there, but what's kind of funny about it was it allowed me sometimes to take a step back, and I spent a lot more time with a lot more customers, a lot more of my small tire power adder stuff that I cut my teeth in, but it kind of maybe moved away from a little bit and kind of got back in there. And it's kind of funny is as much as stuff as I've learned in one place, sometimes you learn it in one and you can take it over into another. And so that's where, if you ever, and not to pick on any of them, but you get into any, let's say, pro category, and the tuners, the people that are involved, they really get tunnel vision because they really spend all their time dedicated to that one thing. And it's not necessarily that it's right or wrong. It's just you sometimes can't see the forest through the trees is kind of how I like to say it. But consistency is key no matter what, because that's how you learn.
Let me ask you a question, and this is not clutch related. I don't know if anybody's ever asked you this, but you said you broke your neck about 8 years ago. How has changes in safety equipment, and would those changes have made that accident not happen? I don't know the details of the accident, so maybe enlighten us, but I'm just curious.
Okay.
Like, for example,
well, I mean,
I wear a Hans device, and I think when Rich and I started going faster and needed those, I absolutely insisted that he get one because if I'm not mistaken, you had a collar, right, Rich?
I did when I first, when I first started, yeah.
Yeah.
Well, so, my accident was a little bit of a freak thing. Most people, that know me in person know that I'm 6'5". When I broke my neck, I was about 240. I was just big. As they always joke, which was, they always joke, getting me out of the car was like, trying to take basically a linebacker upside down, out of a clown car, basically. And really what was funny is it wasn't the frontal impact that actually got me. And most people don't realize what caused the accident was really that I kind of had underpowered it a little bit. We had a new engine program thing we were working with. I was kind of playing with some stuff, and basically every time it was trying to basically kind of drive me to the right every little bit. And so usually in a pro car like that, they're very obviously we make 1,500 foot-pounds of torque, and so basically I'm trying to nudge it back, and I would. And basically when I shifted into high gear, I hit it right on a bump and for a little bit too close to the center. And when it did, all 4 shock travel sensors basically came off, you can't really tell in the video, but kind of full extension. And so basically I was doing a bad imitation of an airplane. It stuffed into the wall on the left-hand side, about 8.5 Gs. Believe it or not, all I got out of that was about a thumbprint bruise right here from my Hans device. And Hans did its job 100%. The problem is there is actually a rule to this. Is you're supposed to have 2 inches of clearance between your head and your roll bars up top. And they wanted us to, obviously, we're supposed to run the poured seats. And when I put my car was built without a poured seat. It had a small little, like, special seat, like a padding in it, but not an actual, what they call the poured seat. Right. And so I'm the only way I can put it, I fit like 10 gallons of crap in a 5-gallon bucket in that thing once we put the poured seat in. No matter how thin I chiseled it, it still wasn't really that great. And so anyway, that was always kind of a concern. But it was really that I landed on my top, and it's only about 2.5 Gs, which really isn't that much. That's the thing that I really like to tell everybody, because 2.5 Gs, that's nothing. And I landed just smack down on top of my head, and had about a 2-inch crack in my carbon fiber helmet. And what it did is it actually fractured my C5 vertebra completely in half. And so basically at that point I was life flighted, went through the whole rigmarole, and obviously most people can look it up, but I was paralyzed completely, nipples down. My hands still have a little bit of drawback in function. I walk with a walker. I'm not 100% that I used to be, but I'm still pretty stubborn. About anybody will tell you that. But some of the stuff that I wouldn't say that it was kind of funny. I've had some things that I've thought about as we're doing some things in our pro stock stuff now. Luckily, my drivers that we've got are both, and I should say all 3 are a little bit, they're, Kurt, their granddad's a little taller, but he's a little skinnier, a little smaller, but they don't really have the clearance issues that I had. And that's something we've considered as me climbing back in, because once I'm in the car, I actually, I warm them up, just go through everything. I'm fine once I'm in there. Just getting in and out is kind of like a little bit entertaining. But it's something that might happen. I've been considering it a little bit more. But the biggest thing is making sure that is really watched. I think there's a lot of people. I know John Montecalvo really made it. He used to have himself spaced up pretty high in the seat to kind of, look around the hood, scoop, things like that. And I know John made some, provisions and made sure he got that kind of fixed. I think a lot of people kind of figured it out. There are 2 little things, though. One thing that we're thinking about doing, I would like to do, and it's kind of a tricky thing, but we've talked about making our upper belts basically where there's 2 of them. They have the same fixture point, but they have a different location, so that basically you have one that draws you back and one that draws you down. Because that's the biggest thing. People don't think about, everybody thinks about a frontal impact, side impact. Nobody really thinks about whenever all your body weight is flipped upside down and jarred all at once. So that's one thing, but that's a small thing we've been kind of looking at. The one thing my car featured, and it will have it again when Miles is driving, we'll do some of the same things with Derek's. I do run more underbody paneling than a lot of other guys do. Like I have a cover over my wishbone, things like that. And it actually has to do with I don't want any pockets of air to be able to get trapped. So in other words, as the air's sliding up underneath the car, we don't like it to be able to pick and lift. So that was one of the things that a couple of safety guys that got reached out to me after the accident because I stabbed into the wall rather than going over the wall. Because I mean, when I was running about 180 at half track, it's kind of, for all intents and purposes, the car should have kept going up, but it didn't. It kind of rolled over on its side. So, I mean, that being said, would it have helped me or would it have hurt me? Who knows? I do know that my doctor, which is Dr. Green, which, was most famous for the Miami project and, Daryl Gwynn and some of us and Derek Thomas, so on and so forth. Dr. Green, Barth, he's a great guy. And, one thing he told me was, he said, you'd been a half inch closer to that roll bar, you'd have been done, because I basically have a bruise right smack dab in the middle of my spinal cord that's just not likely to ever completely 100%, recover. However, you get most of it back. I mean, obviously, you just keep plugging along. But the biggest thing I would tell people is this. I can tell you right now, I don't really care if you're in a 9 or 10-second car. There was an old saying years and years ago. I used to have one of the banners from my dad's era, the Bell helmet, was if you have a $10 head, wear a $10 helmet. But it's the same thing. People look at neck restraints and they actually think, oh my God, that's $1,000 or that's $600 or whatever. I can tell you right now, there's a lot to that. I mean, I don't want to see anybody really in cars. I mean, if you can afford one, you put one, get one. But if you're running 9, 10 seconds, even not wearing a neck support, not good. I can tell you right now, the donuts don't do much. So,
yeah. And thank you for that. I think the whole safety thing is way understated sometimes. And it's legit. I mean, you get into a 9-second or an 8-second car, like it's serious. And when it gets out of hand, it happens really fast. So, I know I like to think Rich and I are both pretty serious about that. I know there's some changes I'd like to do to my car, just to make it a little safer.
Yeah, I know in land speed, I know, they're really, I would say they're top notch, right? Like you can't get in a land speed car until you prove you can exit the car in a certain time. And having to buckle somebody in who's going to go 300 miles an hour, yeah, it really makes you think about how tight you're buckling them in and making sure, everything is right in the car. And yeah, it's a humbling experience that when you get to buckle somebody in and then, when they take off it, idling away from you and then they're doing 300 miles an hour. That's like, yeah, you got to make sure that stuff's right.
So, Cale, you had mentioned something else that you're, always working on designing stuff. Do you have any new stuff in the works, new products? You want to spill the beans?
Yeah, and I mean, I talked to you a little bit about some of it. I mean, some of the things we're kind of doing, it's going to sound kind of funny, but, a lot of people, which not trying to necessarily take a lot of credit of, but I mean, it's like years ago, people used to tell me, some of the people that are in our industry were like, I spend so much time teaching this stuff. And there's a reason I called it black magic, believe it or not. And it was because, the old school way of thinking was you don't really give out the information for free because if they burn the clutches up, they got to come back and that's how you make money. That's the truth. And I kind of, I sat out there for years. I'm watching, everything from our local little 8-mile racetracks to wherever I go. And there's just piles and piles of automatics. And, the funny thing about it is, I don't mind. It's going to sound funny. People cry and laugh. I mean, there is a lot of technology behind fluid transfer, dynamics, automatic stuff. There's no doubt about it. But, the reason that we all, give them a hard time is it's obviously not the same as on driving and tuning. There's more to it in the clutch side of the world. So it's a skill factor. But going back to what I was originally, talking about there, I always like teaching it because my theory was really simple. It was like, well, I would rather, so what that I give this information away or that I teach more people. That allows people and I'll use you guys as 2 examples. The more I can teach you guys, the more you teach other people. And then it passes down. That's that much more likely that we're going to have that many more stick shift racers, that many more people less afraid to do it because even if they can't call me and get me absolutely, because I mean, sometimes I am hard to get a hold of because days get short, out certain times a year, but I try the best I can. But at the same time, it turns into a situation where if it's a small question, it's just little things, they have those tools to learn it. They're not alone. So when we go into design stuff and looking at new products and things like that, one of the things we're working on is, some new diaphragm stuff. Everybody knows me for adjustable clutch roll. And, it's kind of, people a lot of times will ask me, why I don't get into, more of the pro billet stuff. And it's like, well, I do. Obviously, I've got very close relationships with a lot of the other clutch companies. I've either worked with them, worked for them, or done other things. We have partnerships. But, the funny thing is, like I always tell everybody, it's kind of like pro stock is like pro billet clutches. It's where we show off. Sadly, there's not a lot of money in it. It's more of, and what's funny is they're not even necessarily always the best answer to the situation. It's kind of a thing where when we get it, and I'm not going to try to get totally off the deep end on this, but a pro billet clutch is what we consider like an over the cover lever design. So the pivot ratio is a lot quicker when we design a lever. Like I used to do a lot of the smaller pro stock inch type stuff, and got to get to some of the Aussie 400 inch stuff. It gets really tricky. But every engine program, so like down there, they used to have some of these little, Mopars that were turning like 11.3, 11.5, stuff like that. But some of the GM stuff was still turning only, 10.8. Then you had some of the Ford stuff was 10.4. And it was relative because if I used the same lever in every clutch, the car was the same weight. They were effectively using the same tires, same ratios within a little bit, but the engine program was different. So the clutch needed to be tailored different. So that gets into that. And those clutches are made to be, really, yes, you can run them without pulling them out and grinding them and surfacing them and all that, but you do need to maintain that ring height. And that ring height basically is compensating for the wear of the discs, the floaters, and your heat shields. So the problem is after, as you guys know, and everybody's ever run a clutch and worked on one knows, as the clutch wears, the levers, whether it be a diaphragm or what kind of clutch, doesn't matter, the levers are going to slowly come closer to your throw bearing. And as that happens, you obviously make adjustments. If that lever is counterweighted, that counterweight lever is now tilting back more. The more it tilts back, the quicker the counterweight comes in. So like if you're using like our clutch dyno, we go out and we start playing with it, we're ramping them up. I can run them up to about 10,000, a little over RPM, and we can log it. We can look at different things. And that's something I've actually been kind of working on right now, because I kind of came up basically with for lack of better words, a mathematical formula by testing and playing with it, kind of reversing it, that I can get within a small percentage of what I think a new design is going to do before we test it. And it works pretty good, but I still, obviously, we play with them. But what people don't realize is we also look at controlling the engine's rate of acceleration. So, turbo cars, for example, are way different than, say, a naturally aspirated or a nitrous car or a supercharged car. They're all different. And so basically the reason I'm going back to this is, a pro billet style clutch isn't necessarily any better than, let's say, a long style type clutch. By the term long style, there's a problem with this. People out there are so used to, you say long style, they envision a stamped steel cover that has, that is very, for lack of better words, old looking. Okay. And the old stamped steel covers were made by just a handful of people. You understand the tooling, the dies that it takes to make these. There's only a handful of people that have them. I used to work with a company that made all the ones for McLeod, actually. And good, nothing wrong. It just boils down to, when I have all that tooling and you've got, say, $150,000, $200,000, depending, it could be way more than that, depends on which style you're looking at, but you got to keep that tooling up. And the problem is when you make those dies and you make all that and you've got to make these covers, now I am stuck with those fixture points. So that means that yoke has to bolt exactly there. That lever has to go exactly there. There's only so many things that I can change. So that's where you see, several years ago when I was working with Ace, it was a thing where we came out with the next gen. Basically, I came to the table and said, all right, they wanted me to come on board and do some stuff with them. And we did. And one of it was the next gen. The next gen was a thing where I was like, let's basically take what we got as a long style. Let's move some fulcrum points. Let's move some stuff around. Basically, what I would call that is generation one of a long style lever change. And obviously that's, that's what Rich is running. Since then, we've kind of moved on. It's still a great unit, but we found some things. That was something I did, about almost 8 years ago now. It was right before I broke my neck. About 8 months before that's when I sat down. We did all that to begin with. So since then, we've done the Defiant. there's little things we learned. Defiant is kind of like a nice hybrid between a pro billet clutch and a long style clutch. And the fact that we have the long arm, and so when we say long style, it literally means the length of the arm. If you ever look at it, we're not looking at necessarily all the other functions of it. There's other stuff out there that's done similar designs over the years. And you could even look at an older AFT. You could look at some of those things out there, but they're still different. It's still not the same thing, because back then the technology wasn't really available. Is the best way to kind of look at it. It was a little more trial and error. Try this, okay, like it, that doesn't work, whatever. Now we've kind of moved past that, and we have the ability to do a little more engineering without actually having to just make lots of parts and new pieces and hope it works. So the newer long style lever, for example, it allows us to have a slower ramp rate. I can actually go in there and change the pitch of where that lever starts at, how much weight is on the inside of that lever versus the outside of that lever, and the same clutch might be able to work for a way larger option. So I may be able to take it everywhere between a guy that's got 3,000 pounds and 400 horsepower and a guy that's and turns 6,000 RPM. And I could also take that same unit and maybe go up to some days, make it 800 horsepower, turning 9,000 RPM, and 3,500 pounds, and different tires, different everything. So it's all about looking at the data. But as far as the new design stuff, I am kind of getting into. I'm going to go down the path here. We're working on some new diaphragm stuff, because there is a large market when it comes to diaphragm stuff. And not to get into the, I don't want to say stay PC with this might be the best way to say it. But when people go out there and they're looking for different products, the problem with diaphragm clutch stuff for me has always been so many of the questions for someone running a diaphragm clutch. It's kind of an on-off switch. Yes, we have Bill's, bang shift, Billy that ups that, that optimizes that release thing. The situation, though, still kind of it comes back to, for me, is it turns into a thing where my stuff, my adjustable world, it takes a little bit, what's the right way to say this? There's a little more complexity behind it. But what we're starting to see is you have people who want to use the horsepower and they need something that's going to last. They need something they can beat on. And then they start going out there and they start researching it. And I don't know if anybody else sees this, because obviously I've been around my pro stock people for so long, but I always get a kick out of it for years, how everybody would start talking about what oil do you run? What rear end grease do you run? Blah, blah, blah. And I mean, I've watched the engine builders, go and they'll tell you whatever brand to run is, I hate to say it, it's whoever they're making money from. It's whoever's giving them something to put the sticker in the dyno room. And, for years I ran Royal Purple 11 Light. I mean, just religiously. And then what was funny is they gave me a bunch. And then they quit giving it to me. You know what? I still bought it because it was cheaper. It worked. I never heard anything. And the higher price stuff that I had somebody try to get me to run one time, spun a bearing, 2 rods come out. And I said, hey, we're done with that. So long story short is it becomes the market becomes a little bit of, for lack of better words, a little snake oil. Now, that's not saying that any of these clutches that are out there are bad. That's not what I'm saying at all. I'm saying that so many of them are almost the exact same thing, either painted a different color, spun just a slight bit different, and the prices are largely variable. The same clutch from different people might literally be a $500-$600 swing, and really, in essence, it's the same thing. So that's where I'm going to work on some of this stuff. But my stuff's going to be a little more for the, I guess you'd say, a little more top shelf. Higher horsepower. Now, don't get me wrong. It'll, you can obviously use it with less. It's going to be made to take a beating. But there's some things out there that we're going to work on once again. And I'll bring up, since I've got, Bill here to talk about it, I'll bring it up. A lot of the biggest thing, and Bill can tell you, is, when you do any type of a release, type of a situation on controlling your pressure plate's location, in essence, it's got to be able to have, it needs to be able to take a beating. It needs to be able to be robust. It needs to have materials that are made to work with it. And if they are, it'll be consistent. It'll take that beating. It'll put the miles on it. It'll keep going. And at the same time, we've got a lot of people out there who they may not even be looking at adjustable clutch stuff. They may look at it and go, I don't ever take this thing to the racetrack. And let's face it, as everybody says, they're all going to Mexico. Okay, not my thing. Power to it. I still want to make them fast. I mean, obviously, but I even my guys roll race. I get it. We put that out there. So in essence, what I guess my point is, it still comes back to the same thing for me. I'm wanting to make durability and longevity. It's not about making the lightest thing you can make, because good Lord knows I've played with pro stock stuff my entire life. I know, and I could go off the deep end on this to tell everybody, when you get into weight of a clutch assembly, rotating mass, there is a point in which, you don't want the heaviest thing back there. There's also a point that thing better have enough thickness in certain places that it can do the same thing twice, that it can get rid of that heat. It can stay flat. Because if it can't stay flat and it's always going back to your clutch guy, that's not fun either.
So Cale, let me ask you a question kind of along those lines then. So let's say you have 500 horsepower or less car. Can you put a clutch in it that'll handle 1,000 horsepower? But if you're using a device to manage that clutch, like the Bank Shift Billy or any of the other ones, is that still viable? And in that case, would a clutch last longer? I would say that really depends on the disc, and we'll get into that about disc availability and materials. So,
yeah. So there's a kind of a trick. There's a little bit of a couple of different ways to look at this. Let's just say, let's give a really exact example here. Let's just say a 500 horsepower car, let's call it 3,000 pounds. Let's say it's got a TKO, TKX, something like that in it. Or even a T56. It's got something in those realms. It's small tire. Most it ever sees goes to racetrack, a little 28-10-5 on it. And let's just say, for argument's sake, the thing doesn't turn more than, say, 7,000 RPM, something just kind of really run of the mill. In that type of a scenario, I could easily put a single 10.5, single 11-inch. Obviously, my biggest problem, say it's a Ford. This is something I'm going to throw out there. It's a Ford. We got a 157 tooth flywheel. We can be a little limited, but
that's what I have, as a matter of fact.
Right? Exactly. And so I feel like, you're in a situation where I could put a single disc clutch in that all day long, and I could run a cerametallic, and we won't get off the deep end too far, but let's say a cerametallic, which is still a centered material disc, a metallic disc. I could use something like that. I could use a full centered iron disc. I could use something along those lines to hold that all day long. So to answer your question would be, let's just say hypothetically, now I'm going to put a twin 10.5-inch with a stamped steel cover, but maybe what you got, aluminum cover, doesn't matter, but it's a 10.5. That part doesn't matter. But a 10.5-inch, we're looking at a friction coefficient. So let's just say I almost double the friction coefficient. Okay.
Yep.
So now that thing could handle 1,000, 1,200 horsepower, something like that, instead of the 500-600 horsepower we're dealing at. So now what happens is there's a couple of things you can do. It will help the Bank Shift Billy in that application is going to help our short time. No question asked. That's for sure. The thing about it would be the longevity aspect of it. The trick with that is going to be the fact that if we can, once again, this kind of comes to some of my new product design stuff, but there's some things we can do heat shield wise, heat dissipation wise, material selections, things like that, how the floater's driven, so on, that can really help the longevity. So obviously, if I put 2 discs in there instead of 1 disc, it's going to last longer. No questions about it. Because obviously I've got that much more meat to eat through.
Right.
And so, I would say you would probably at that point, when you're starting to talk about throwing, let's say on average, an extra disc, extra floater, some stands, you're probably throwing about 6 to 7 pounds of extra rotating mass on the back. I would say it was okay. I would say 100%, if that's what they're looking at, it would be okay to go that route, because the amount that you're going to lose for horsepower of rotating that thing versus what you can get out the hit all day long, that's more than a fair trade. You're going to get a lot more on the launch than you'd ever give up. So yeah, that would be what I would say. I guess the best way to probably answer that in a very layman term, easy, straightforward way of saying it would be, I wouldn't recommend any release device, period, that is underclutched or right at the edge. Meaning, if you got some, and I don't rate everybody else, almost all my customers are probably ever talk to me, I'll tell you, I will never, ever, ever say I rate a clutch off of horsepower, because there's way too many more factors out there. You just can't do that. But let's just say that single disc clutch you got is on the edge. If you do something that's basically got it turning really, really fast, and what we would have with your device, as an example, I basically got a sanding disc spinning really, really fast. And I always use this example. It's like, think about just going out on a wheel and you take your fingers, you really slowly squeeze that sander disc, it's going to hurt. If you pinch it really fast, it won't hurt. So basically, that's how to look at it. So it's not that it's necessarily a bad thing. It just means we need to build the clutch or select the clutch, or however you want to look at it, to basically do what you intend it to do. Because the funny thing about it is it doesn't make the product anything wrong with it. It basically is kind of the exact same thing of when someone used to call me up and go, Cale, can you build me a clutch to save my third member, to save my transmission? Well, not exactly. Yes, an adjustable clutch will help it because you're not hitting it all at once. Yeah. But if I make it I really back it off enough to save everything, clutch is going to take it. You're just going to kill my clutch, you know? Yeah. So it's kind of the same thing. And it's the same things when guys call me up in, you know, the crazy horsepower world, and they say, hey, I tell them they need this, this, and this, and we get into shocks, and they'll tell me what they got for shocks, and you're just and you'll tell them, listen, you need to get this, and you almost hear the dead spot at the other end of the phone, you know, of like when you tell them what they need to do, and you're like, it is that necessary. You just spent, this much on this, this, and this. Like, yeah, that ain't where the piggyback stops. So
yeah, I might have had dead spots before. Oh yeah, you're right. I probably do need that, but how are parts to get for you these days? Like you typically are putting together a bunch of pieces. Are the discs getting easier right now, or your newest clutch? Go ahead.
Yeah, everything's gotten a lot more freed up. I mean, we had several different things that were there that were just it's kind of, the industry obviously has been a little bit of a nightmare. I mean, we still have some slight things. We just have to do a little better planning just for some longevity on some stuff. Because, I mean, there was several things that really was out of everybody's control. There was a few things that were just bad decisions, and I would say bad moral decisions on other people's, sides. But at the same time, I've done everything we can to make sure we keep everybody rolling. We're getting pretty well stocked at a point where it's not really an issue. But, this world's been crazy. It's been like our pro stock stuff this last year. I kind of had to leave the training wheels on Derek a little bit, I guess is the best way to put it, just because we couldn't make a lot of extra runs because, rods we put an order in for, 8 months before we couldn't get. Finally, we had an opportunity. We got them. Now we got rods coming out our ears, or so to speak. I wouldn't say that much, but we're not in the uh-oh vision. So no, the industry's getting better. I think the problem with it is everything is still fragile. We're getting into that situation where if one little domino falls, some of the others can fall behind it. But I've tried to kind of get to a point to where we at least know that we're good for, 3 to 4, 5, 6 months, however we can go on any given part. But we pretty well caught up. Last year was a little bit of a nightmare, but we've caught up a little bit. And the biggest thing that I get into, most people know, and I can get off the deep end as far as the single disc, twin disc thing is a whole nother deal. But there's a reason a lot of my guys that if I can make them run a single disc over a twin disc, it has to do with shifting, has to do with ease of things, has to do with parts, this, that, and the other. And so, the 11-inch stuff, like the 11-inch, next gen 11-inch long style, the 11-inch Defiant, I'm about the only person that uses those. So that has to do with a carrier, that has to do with stampings, then it has to do with material, it has to do with everything. So when it turns into a situation where all of a sudden we have, where our production side is waiting for powdered metals and we're waiting for this, and we're waiting for that, then all of a sudden it turns into a whole nightmare. So basically what we thought we were going to have in about 4 months turned into about 10 months, and then snowball effect happens. So no, we're trying to pump them out as fast as we can.
I'm going to stop you there. I still remember when you told me what you were going to send me. And like we talked about earlier about the stack of clutches and the different clutches I was running, and you're saying, I'm going to send you a single 11-inch adjustable clutch. And
you were like, no way.
I am not going to work. They not going to work. And I still remember I put it in the car. I go for a drive. I'm in 6th gear, and I give it a little gas, and it slips a little bit, and I'm like, oh man. So I call you up, and you're like, well, just throw a little counterweight. And I'm like, Cale, you don't understand. I'm only doing like 1,700 RPM. What's a little counterweight going to do? And he's like, put on the counterweight. And yeah, I mean, I literally drove to Florida and back with that clutch. But it is amazing what you can do with a single disc, especially the 11-inch stuff. Yeah, it's 4,000 pounds and 1,500 horsepower running 8s, and the 11-inch, yeah, it doesn't wear out. Like I think I said it back to you 3 years ago. So, and and just had it refreshed now. And I don't know how many miles I had on that thing, but it is amazing what those 11-inch will do. And I'm going to say it, even compared to the dual 8 that I've also ran, like in the durability. So
well, and
it's pretty interesting technology.
And if I can add something to that, I am a huge fan of the single disc over the twin disc. I don't know that we have a solution in a diaphragm that will hold the power that I'm making, but then I might be buying another clutch. But the problem that I see, especially because I get a lot of guys, I mean, I know Rich does too. I get a lot of guys asking us questions. The problem with a twin disc clutch, especially sintered iron, because those discs are so heavy, if you're running a synchronized transmission, dude, it's gonna just beat up on those synchros. It's rough on them. And Rich and I both have faceplated transmissions, and it is quite possible we don't use the clutch except for the launch. So it doesn't matter. But I can tell you that in a synchronized transmission, yeah, I always try to run a single disc if possible. So tell me what you have.
You bring that up.
That kind of power in a diaphragm single disc. That's what I want to know.
Something I'm working on, a ways from it, but it is something that kind of came up that, yeah, it's a little bit, let's just say it this way. It'll be something that'll kind of throw everybody for a loop. I don't know when I'll get that done because that's a little bit of a large project, but I am working on it. Okay. I've thought it out for quite a while. So it's funny you bring that up. I've had a lot of people ask me, they look at different things, and it's funny because there's different selling points in this world. There's they'll say, okay, a twin disc versus a single disc. And then they'll say, they get into weight, they get into different things. And other people will either say market push, whatever about, oh, this thing only weighs this much, overall size. Once again, there's so many factors. Can I go and get, it's like somebody call me up, one of my customers, and say, hey, I want something like what so-and-so is running. You want me to build you a twin disc 7-inch, 8-inch, 12? I don't care. I can do it all day long. Sure. I can make a pro billet. We can do all that. Do you want the maintenance that goes along with it? Do you want some of the things that are there? Almost every one of them will be like, well, wait a minute. I want to be able to street drive this thing, like Rich does. I want to be able to I don't want to work on this thing. So so it's really a catch-22. So, they compare it to somebody I would call as a race car, a shop car, something that the thing comes home and it gets taken apart and everything gets serviced 100% versus the weekend warrior guy. Yeah, he's got a lot of horsepower. Yes, it's got the potential, but he's not going to spend, 30 hours a week working on his car.
Yeah.
So that kind of becomes an issue. Back to the synchronized stuff. I can think of one guy, a customer of mine was Bryant Rogers, and really good kid, military guy. And he was, basically messing with, I can't remember what year exactly. I want to say a 13, 14 Mustang, fully synchronized, hardly any data logging on it. He had the exact same clutch that Rich has got in it. And the point I'm making was the thing that he got into, and we deal with this, and we'll get it. There's a good thing. People always ask me if we're running my style clutches, linkage. I'm like, take hydraulic and get rid of it if it's an option. Okay. If we're running an adjustable clutch, that's a different story. Okay.
Yeah.
So that's my point. If I'm not running an adjustable clutch, it's a different ballgame. But the reason for it is because when you take that away, it becomes a little bit more handy. And so, kind of what I mean by that is we want something that does exactly the same thing absolutely every time. That's important to us. So back to the thing, the synchronized stuff. We start getting a lot of these guys, and Bryant would be a good example. He was spinning over 8,000 RPM. When you get up there 7,800, 8,000 RPM, that counterweight's kicking. She's pushing. And so for him to run enough to hold what he was trying to do, that became an issue. Now, when you push the clutch pedal down and you're trying to get air gap or release, clutch release, when you're trying to do that, let's say I've got it set up in the pits at ambient temperature at 70 thousandths. That means for everybody listening, let's say you push the clutch pedal down and I can take a 70 thousandths feeler gauge and shove it between my disc and the pressure plate with the clutch pedal down. That's air gap. Not to be confused with free travel. Free travel is the bearing to the levers when there's nothing being pushed down. Okay. So let's say this guy's got hydraulic. He goes to push his clutch pedal down. Now he's going down the racetrack. He's done a burnout. The engine's up to temperature. The clutch is no longer 85 degrees. The clutch, the flywheel, and everything is 130 degrees. That 70 just turned into 50. Okay. So now your situation goes, because everything's expanded. As everything expands, that air gap gets smaller. So they go out there and he's pushing the clutch pedal down. Let's say he's running hydraulics. And that hydraulic situation is once again, not to get off the deep end in fluid dynamics, But you get into a situation where, let's say that master cylinder doesn't have quite enough in its sack to freaking get the job done. And that clutch is throwing that counterweight back up there at 8,000 RPM, and he goes push that clutch pedal down. It don't get me wrong, it might have a little release, but it's not enough. Maybe it can't travel enough. Maybe that now at 55 isn't enough to do it. So that synchronized transmission basically is in a situation where, regardless of what disc is in it, now that disc is sitting there tinging off of that flywheel, and it's sitting there spinning. Well, as long as that thing's spinning, that input shaft's trying to spin. As long as that input shaft's trying to spin, those synchronizers are not going to line up. So he gets blocked out. So what can that guy do? Several different things. One, if he's running a hydraulic situation, he's going to probably have to put a bigger master cylinder in it. He's going to have to put something in to make sure it can travel what he needs it to travel. Okay. But let's take the hydraulic side out of it. Let's say he's running mechanical and he's getting blocked out. Let's say it's a Fox body Mustang or, something like that. And they're running the cable. Okay. He's going to push it down. And I'd say, you know what? Open it up. Let's make it 90. Let's make it 100. There is a point. Don't go too far. And what I mean by too far, this gets a little bit ticky-tacky this is probably off the deep end to most, but this is we call clutch slap. Meaning when you're up there on the starting line on the two-step and you sidestep the clutch and that thing goes and it basically, let's say you have a whole ton of air gap, it's going to kind of like momentarily in the data go ping off of it. You'll see a little tick in it. So it's like it momentarily kind of skips off, the pressure plate skips off your disc. Okay. Not a big deal. Yeah. It's not a big deal, but you don't want it. So my point about it is, if you got a guy's got a synchronized trans and he's turning a lot of RPM and he can't quite get it there, get a little more air gap, get a little more release on this thing. That's going to help you. The other thing to keep in mind, and this is where I kind of get off, the deep end, which a lot of guys once again talk about these twin discs going small, this, that, and the other. Yeah, I can build them all day long. But the situation is two discs. Let's take the weight for now. Let's take the weight of one disc versus two discs out of the equation. Let's pretend that doesn't matter. But I can tell you right now, 2 8-inch discs weigh more than one 11-inch disc if you're running any thickness at all on your disc. But taking that out of the equation for now I have two discs in a floater, and let's say I'm used to running about 70 thousandths air gap. Now that air gap is divided by two more surfaces. We've got a problem here. So in other words, I've got to get that much more release in order to do it on that synchronized transmission. So in other words, you need more air gap to do the same thing. But then to go back, you're going to throw the weight in it. So I guess what I'm trying to say is at the end of the day, there's different ways to skin this cat. But generally speaking, if I can get the job done with a single disc, I will. And I'll tell you what, I'll go down this story path. It's a short one. It's pro stock stuff, mountain motor stuff. I use this a little bit, and I always tell everybody it's like comparing an apple and a kumquat. I get it, different worlds, but it's fairly easy to understand them. Probably, I don't know when everybody started this stuff, but back in the mid 2000s in the mountain motor world, everybody's always ran a twin 10-inch clutch almost religiously. Almost any, I'm not saying all of them, but if there's 25 on the property, 22 of them have a 10-inch in them. And twin 10-inch is what we'll run. Now, that being said, there's some new stuff, that we can do there. We're all starting to kind of look at, but for years back, let's say 15, 20 years ago, people started thinking we can do this with a triple 8-inch clutch. The triple 8-inch actually weighed about 8 pounds less than the twin 10-inch. And so everybody was like, in our world, you're thinking 8 pounds, that's got to be worth some horsepower at the strike. When we're all within a few horsepower of each other, we're all running within a half a mile an hour. And that's the thing I try to tell everybody where I come from is I remember when I first cut my teeth doing pro stock stuff. It's been a long time ago now, but when you show up at, old Rockingham and you got 32 cars qualifying for a 16-car field, and the first 5 that didn't qualify are still within, a few thousandths of the field, you get a little more anal about things.
What about the hit?
Right. Well, but they're all looking for that little bit. They're looking, how can I find it? So a lot of these guys, they started putting the triple 8s in like crazy. And what they found was now it seems obvious, but back then what they figured out real simple, our tuning window got really small because our friction coefficient went up. When our friction coefficient went up, it meant our applied pressure had to go down. Then we moved that lever closer in on the geometry. And so basically what it did is most people would tell you that it could be just a little bit quicker, just a little bit of ET, but it wasn't worth it because everybody shook twice as often. So everybody was like, would you rather go down the racetrack?
Yeah, let me add something else. the pieces you talked about make sense too, but you also lost 8 pounds of centrifugal momentum, if that's even something, but that's stored energy.
Well,
That's another piece of it as well,
so
right?
so to talk about that, that's something that I usually do in my clutch tuning seminars. I'm going to pick on you here a little bit. So it's usually my older guys that kind of bring this. So I'll get these older bracket racers that'll come in. I've always got the one guy sitting there, and he'll say one or two of them, and they'll be like, after I go through all the weight things and I explain things, the guy's saying I make 550 horsepower. Let's just say he's a stock eliminator guy. You know, he's basically out here in a 3,400-pound car on a 30x9 tire and old Jericho 4-speed. Basically, as run of the mills we can make, and he's got a single 10.5-inch, you know, say a McLeod soft block in it, and he's had the same thing for the last 40 years, whatever. Okay, and he'll tell me I've got to have that big, you know, 30, 40-pound steel flywheel in there because I need that inertia to get that tire turning. No, you don't. And there's several different ways to look at that. That's a catch-22. And I can tell you by looking at lots of data, lots of my customers that I've talked into it, and I've taken them out of their old, say, 10.5-inch stuff, put them in a 10-inch unit. I tell you, a customer, he'll probably watch this, is John McLaughlin, one of the most meticulous bracket racers I think I've ever found in my life. I remember he'd send me data and send me like all his logbooks and everything, and I'm just like, oh my God. I was like, I like, this guy takes it to another level. However, you know, I was kind of explaining some things to him, and he's seen it. But my point, though, is that he was never one of these guys, by the way. I'm not putting that John in that group. But my point of it is I had a lot of these bracket racers that would come to me and say, I've got to run this big old heavy steel flywheel. And you look at their data, and you'd show them. And as soon as they put the lighter unit in there, they would see something. You need the wheel speed. Yes, that stored energy does help on that release, but there's other ways to get that. You can stiffen your compression. You can put air in the tire. You can run a smaller tire. You can run more gear ratio. You can launch harder. You can put more weight in the front than in the back. There's a lot of ways to encourage wheel speed. If you're putting all that weight in there, the problem with it is what happens the first time you shift? RPM goes down. Now it's got to go back up. Now that guy making 500, 550, that sounds like a lot of horsepower to some people. But in the grand scheme of things, I can tell you right now, your gear leverage, especially on 4-speed applications with big gear drops, not good. So if I've got a car that when I launch like I'm looking at a data log, and if let's pretend we're not looking at a data log, and let's have a little fun here, and I'll be a dork. So I'll do this. I'll do the sounds. If I'm sitting on the starting line and I hear guess what? You don't have enough horsepower for the weight you're running to get the wheel speed that you need. So those guys, if they do all that stored energy, they literally will get a little bit of a tick of drive shaft RPM for about less than 1/10 of a second. And then they will pay for it in every gear change because it has to recover. It has to, okay, now we're going to throw in steel material. Well, it doesn't dissipate heat. It doesn't do the same thing every time. There's some other things. Now let me talk on the opposite side of this. Let's talk about being very, very, very light. Okay. So I can tell you, let's use stock eliminator cars. Let's say most guys between 450 and 800. That would pretty much cover all of them. They're all between 2,900 and 3,500 pounds. They're all going to run a 30x9 tire, and they're almost all going to run a 4-speed. Basically, in those type of situations, I can tell you right now that data-wise, looking at the optimal weight of, say, a single disc 10-inch, which they're all going to run, somewhere between about 27 pounds and about 34 pounds, you almost see no complete difference in mile an hour in anything. It's very, I mean, if it's there, it's nominal. It can be made up somewhere else. You're basically pinching pennies at that point to try to find something. When you get too light, the biggest problem you get when you try to lighten up a clutch, it's like any other part in your motor. I don't care if it's part in the motor, part in the transmission, rear end. When you lighten stuff, you are taking the structural durability out of it. Okay. So that becomes an issue. A good point that I always get a kick out of is a lot of guys that are young guys, I should say, that, you know, in the engine world, they think, well, let's say a push rod. They're going to think, well, I want the littlest, thinnest, strongest push rod I can make. Do you? No.
No.
Well, they think, well, that big old thing's got to go up and down. Yeah, and you pull one of our push rods out of one of our 800 inchers, and you're like, oh my God, you know, and they're like, that's the size of my connecting rod. And so, you know, the whole point about it is, it has to do with, there's places you gain it, there's places you don't. And can I make like a clutch. Can I make it really light? Yeah, we can do that all day long. I can make a lot of my stuff way, way lighter. And if they want to work on it that much more and they want to send it back and buy parts that much more, we can do that. But there also becomes an issue where I don't know very many racers out there that go to a racetrack and don't hopefully plan on making 8 passes at an actual event. Let's say they get 4 qualifiers, and if they win the race, they got 4 eliminations on the low side, especially in bracket racing. So you got to make 8 runs. And let's say you put a clutch in, and now I'm running little, let's say 140,000 thick heat shields, little rivet on suckers. And you go out and you run that thing. And now I've got an aluminum flywheel, and I don't have any real material back here behind it to sink it out, pull it out. Now what ends up happening? You got a brass rivet, I got a little thin steel heat shield, and I got a big chunk of aluminum. And they're all going to expand and contract. Just balloons. It's a waffle when you're done. And so it's a potato chip.
I don't have any of those. I don't have any of those warp clutches in my garage.
So it just turns into a situation where, it's like how much can you really take off of it? And I've got some of my stalker guys. By the way, John Korish, if you're listening, love you to death, and your clutch is almost done. However, I told him one time about the lightning of the flywheel, and John's him and his son, great racers and do great. And it's, I've had a lot of fun, playing with him here recently. But it's a thing where, he runs basically in a situation where we're lighting it up, 168 tooth, flywheel. We'll put a little bit of pockets that are on the outside edge. But like I tell him, we're talking about maybe taking a half a pound off this thing. Probably not really that much there. We'll do it if you want to, not the end of the world. But to go back to it, it all has to do for me is longevity. So it comes back to, if you come back after 2 or 3 runs and that clutch, now if you were to take it apart and that disc is not touching from the inside to the outside, the entire surface. And let's just say you take off 5% of your friction coefficient. That's a change. That's a significant change. The only way it's not a significant change is if you are putting so much extra pressure to it than what you need. So let's just say you're running 30 grams more counterweight than you should be running and 3 turns base more than you should be running. Yeah, it probably doesn't matter because the damn thing is so locked up, it's not doing what it should anyway. But if you get close and you look at a graph and you see it out there and that engine RPM's coming up and that clutch RPM's coming up to match it, 5, 6 tenths in, and it's giving you just a little window in the bottom of your gear changes, that's when you're getting close. At that point, that clutch had better be able to stay flat. It better do the same thing every time.
So I'm gonna
drag you back. I'm gonna drag you back to an earlier point. We were talking about you mentioned clutch switches. We've talked about this one on here before, and so 2-step clutch switch. When exactly do you want your clutch switch to deactivate your 2-step? My understanding is once the throw bearing is just basically going to start coming off, so the clutch is fully engaged. Is that right?
Correct. Yeah, and so I always tell people the backwards way so they can imagine it. But I always say, pretend you got mechanical linkage. You're going to take your hand in there, push on your clutch pedal, and we always set our clutch switch up to have a light on it so that you can look at it under the dash. So I can take my hand on the clutch pedal, I push it down, and the moment I feel that bearing touch those levers, that's where that light should be turned on. That's your 2-step switch. So in reverse, as the last is coming off, the absolute second that tickle is coming off that's where it should be maintained. I get a lot of guys will put it either at the very base, bottom of their, all the way down at the floor, or I have guys will say, "Oh, I'm just running it off my line lock." You can't do that. It has to do the same thing every time, because otherwise you're looking at data, and if your thumb didn't come off that thing at exactly the same time every time, place in the travel of the clutch every time, you're going to leave it a different RPM every time. And one of the biggest advantages to an adjustable clutch, especially even with the bang shift Billy, same thing. It's got to be a consistent leave RPM. We can't be all over. It's kind of like several years ago. Most people don't probably know this. In the 500-inch stuff, when they went to the Holly, there was a provision where the problem was when you looked at the 2-steps, like you looked at the data, the engine RPM was within 500 or 600 RPM. It literally was just everywhere. And, they were like, well, what are you going to do? Well, anybody that knows anything about stick shift racing knows we can't be guessing within 500 or 600 RPM. We need to be able to go up 100, down 100, anything like that. That's important. So, so yes, that's the right place to keep the two-step switch. And most of us will use, there's obviously many different ways you can wire this up, rig this up. There's different ways, but yeah, that's where it should always be maintained.
So let me ask this. You talked a lot about pro stock racing and stuff, but obviously we do a lot of drag and drive stuff. And I think a lot of the listeners do too. And Rich has talked to me about this because you have a twin disc 8-inch clutch that's significantly lighter than the single 11-inch. And you notice some drivability issues. Talk about that, Rich, because there is a difference on the street.
Yeah, just it's actually low RPM, low load cruising. The Cale's clutch compared to the dual 8-inch, you get into the herky jerky movement a lot more with a lighter clutch than you do with a heavier one. And when I say heavier, it's probably 8 pounds heavier is the difference between those two clutches. So for me, the streetability with the 11-inch is actually it's quite a bit better than my dual 8. I mean, I can make them both work at the track, but so it's interesting. I think it ties right in. I would say I've experienced exactly what you've described with a lighter clutch and a heavier clutch. For a guy like me who puts on stupid miles and, goes, I would say, relatively quick at the track, the durability difference is definitely noticeable with a heavier clutch, thicker heat shields. For me, it just lasts longer. And so, yeah, I would say I'm a testament to what you just described there. So another one, I mean, because this is our podcast, so I might as well be selfish. Is there a point at which an adjustable clutch, in your opinion, and I think this ties right in with what Bill's doing, how far into the run would you want it to lock up? Like, is it like 0.7 seconds, or is it very dependent on, you have a lower horsepower motor, so you got to slip that clutch and let it lock up quite a bit higher. Do you have a formula for that, Cale, or is there a?
I've honestly been asked this before, and it's I'm going to try to make it not such a long-winded answer. It's everyone's a little different, and so. Okay, so everybody will hear me tell them whenever they say, well, what data points do you want on this car for you to tune from? Well, the most important for me is drive shaft RPM, number one, because drive shaft RPM is a direct correlation, obviously, to wheel speed. But that's going to tell me several different things. I do, at some point in some of my turbo applications, like to see a mile-an-hour thing, and it has to do with a little bit of tire slippage so we can see what relative ground speed is comparatively. But that's getting off on way different tangent. That being said, the drive shaft RPM is the most important. So, for example, to bring it back to the pro stock stuff to make sense, the quicker I can get you out of first gear, the better. But when you get to that certain point, you can get to a point in which it's too quick. Like in other words, like we're flirting with some stuff here. We're on the edge. It might try to shake. We might have, other problems. So everyone's going to be a little bit different. So let's just say you've gone out, you get your best 60. Let's say somebody's best 60 foot's a 125, just pulling something out of thin air. Okay. Their best 60 foot's a 125, and they look at it and they go, how did I get there? Okay. They're going to go back and you look at your drive shaft speed, and your drive shaft speed, let's just say at a quarter second, at a half second, 3/4 of a second. Let's just say we're at 1200, 1800, and 2400, whatever, just kind of those numbers. And so you're going to try to get back there the best you can. You want to control that. So you don't want that engine RPM basically. So it's not so like even in pro stock, we don't go to each track and go, I want to be out for sure by 0.6 or by 0.7. That's not specific, because obviously we're different. We change gear ratio every single run. We change a lot every single run. However, we're looking at it, how quick can I get out of first gear? How quick can I get that wheel speed? I may get to one track at a half second, I can be at 2,800 RPM. I may get to another track where if I'm past 2,500 RPM at a half second, I'm in trouble. Okay. So it's all going to variably change. It's all going to be different. I can tell you on most applications that would be fairly pertinent to probably most of the people listening would be most of these cars the average is going to be anywhere between 4 to 8 tenths of a second. You probably want to see lockup. Now, there's another thing that does kind of affect this. If I've got a low RPM engine versus a high RPM engine, if I've got a guy that can turn 8,500 and I got a guy that can turn 6,500, that throws a little bit of kink in it because it means I'm probably going to be launching at a considerably lower RPM. And let's just say their launch RPM, let's just say their launch RPM is 4,000 RPM and they're shifting at 65. That guy has a very small launch window. So I can't slip that clutch for, let's just say, at 1,200, 1,500 RPM. I got to lock it up a little bit quicker. I got to do some other things to control how fast that engine, revs. So that's where we'll get into suspension. That's where I'll get into gear ratios. That's where we'll get into boost curves. That's where we'll get into a lot of other things. Or let's say I've got a guy that can turn 8,000. Okay, if that guy that can turn 8,000 RPM can launch at 5, he's got a 3,000 RPM window that maybe that extra 500 or 1,000 RPM that allows me to slip the clutch longer. So every clutch, every customer, that's why I talk to everybody, everything's different. It's not just a, one size fits all by any means. So
let me ask you this then. So when you're slipping the clutch and you look at the data log, you come off the two-step, you don't want to see any dip at all. You want to see that going up to the shift point. But when the clutch engages, do you want to see a dip at all, or do you want to just see a nice smooth transition?
That also depends too. So let's just say, I mean, we're going with the assumption that the car's got enough horsepower to accelerate on the launch versus no bog. Let's say we got enough power to do that. When the clutch locks up, I mean, a very, 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 very pretty graph would be something. And I hate to say, I don't say hate to say it, it just is what it is. You're going to be in a pro car before you see one that's going up and the clutch comes up nice, meets it, and almost doesn't pull it over at all. That's getting everything just really spot on. When you're dealing with heavier cars that aren't, the suspension, everything, we're not quite to that level of, refinement might be the best way to put it. Yeah. You're always probably going to have that little layover. When I'm using a power adder type specifically, and I probably should use turbo stuff because this would be a good opportunity to explain some of this. I've had several of my customers and probably people have seen their stuff, but it's going to sound funny. How many times I've told guys, take power out of the damn thing. Take it out, get it out. And so a lot of times in my turbo stuff, I'll say, we'll bring it up. And we're going to bleed a little boost off at the top. We're going to bleed a little off at the bottom because of how fast that turbo doesn't decelerate compared to that engine. Okay. So that's just an example. But let's just say that we're looking, let's try to use an example. Let's say I got something that shifts about 8,000 RPM and leaves about 5. I got a 3,000 RPM to work with. Let's say it's a 4-speed application, so it loses about 1,800 RPM in the shift. So if this guy shifts at 8,000, he's going to fall, down to around 6,200. If he's launching at 5,000, I mean, this isn't exact math, but he needs to be locked up before 62. Because if not, every time he shifts, it's going to come down there and it's probably going to separate a little more than we want it to. So, but let's say when the clutch locks up right there at about 62. Okay, if it locks up right about there or 6,000 and it lays over a little bit, okay, that means that I look at the Excel Gs, if I got a logger that has it, and I can see those Excel Gs fall off just a little bit. I'm probably going to look at maybe ramping in a little bit of power right there. Not too much, but just enough to help take that out just a little. But what's going to happen is you got to look at it. There's a couple different ways to look at that. You got to be careful because you might put power in and then actually the clutch will lock up that much harder. Okay. So because you got to think about it. If that acceleration rate of that engine gets faster, the counterweight comes in quicker. So what I need to do is I need that if I'm getting everything right, I basically need to time it out just right so that just after that clutch comes in, we give it just a little bit more. We kind of control that ramp rate just a little bit there.
And that's if you're using an adjustable clutch.
I mean, yeah, but I mean, you could do the same thing, with say your stuff. There's things you could do with that. You just got to be a little bit careful because basically I would say that if you had it done right, it'd almost be where you're turning it completely loose. Meaning in your application, until that you've taken the controller basically completely off at that point, where it's given every last bit of force it can have. We know it's staying locked up past that point.
Yeah.
At that point, you could ramp it on in. If it was still, let's say it was locked up, but it was still 10, 15, 20% sliding, we probably wouldn't want to do it because we're probably going to be a little hard on it. So
sure. All right. So let's just some technical stuff real quick because I am curious on the pro stock stuff. Rich has always run a Pilot bearing, and even back when my car was NA, I tried a pilot bearing as well, but I use like an OEM one where the needle bearings rode right on the input shaft, and I trashed the input shaft, and I was like, God, I'm never going back to that. And so I ran a bushing for a long time, and even recently had some made that were of a harder bronze material because I'd literally drive to the track, I'd make 2 or 3 passes, I'd drive home, and the bushing was trashed. And so finally, a friend of our mutual friend of ours, Pat Miker, was like, "You need to get an actual bearing that had, a roller bearing." And I put one of those in, and
Right.
I don't even know how many events, and it's perfect, and it's way better. Like it's, I think that's what you run, Rich, right? Is that kind of? Whoop, you're muted.
Yep, that's what I've always run. Yeah.
Yeah. So what do the guys run bushings? Like I'm going to say the
We
roller
run
bearing
bearing.
is the ultimate solution for me.
Well, in our stuff, our mountain motor stuff, we actually have a ball bearing style. The thing obviously is like, well, it looks like, the back of an elephant. So, we got plenty of room. But yeah, hind end. But no, but at the same time, I usually tell my guys that when you get into bearing bushing, and obviously what you described is two different types of bearings. When
Well,
you
and I
got that
think,
bearing that the
and I
needles are actually riding on it, those leave a little bit to be desired. There's a lot there because the hardnesses and what you're doing is you got the problem that a lot of people don't realize. 99% of the time when you have issues with bearings and bushings, etc., and I mean I've dealt with them too. It's almost always an alignment thing. It has to do something in the transmission bell housing alignment to the block. There's something there that's a little off. But those needle ones like you're talking about, that's basically you're gonna have vibration. That I mean, it's just harmonics. Those things are moving. If they got even a few thousandths in there, that thing's moving and chattering, it's going to flatten those things. But no, the bearing is by far what I would call an interraced bearing. So it's got a surface it's riding on. That's
yes,
by far the way to go as far as performance. A bushing, in essence, is just a softer metal on a hard metal, and over time it is going to go away.
yeah,
But if you got somebody that, I mean, the bushing, I hate to say it, is a fairly safe thing for somebody just out here, regular street car, not making crazy horsepower, not turning crazy RPM. It's okay. But by far, if you're going to go into it and you're doing, we're trying to get the best we can get, a good interraced bearing is by far the option.
perfect.
Okay, before we get into another questions, I hit up Nick Coleman today to be on the podcast. But congrats to him, by the way, if he's listening, or for those people who know who that is and what he just did. But I think he had one of your next gen clutches in that, and he's the first LS powered car in the sixes. So sorry about that, Garrett and Leroy. But congrats, man. I mean, Nick's been busting his butt. Like, I don't know how many engines. He had some issues this year, but man, he persevered. Like, every time I saw it, I'm like, oh, he's done for the year. And then it's like,
Well,
shit, a month later, he's back out again, beating
yeah.
on that thing. And
I think the truck was for sale at one point too.
yeah, and selling the whole thing. So you must have been talking to him, did you, Cale? Have you talked to him since he ran?
I haven't today. It was kind of funny though, as I will say, Nick is like the one that I always enjoy calling, and I always joke. I was like, I think his brain's a little frozen. When I get you, hell, I got Rich further north, But no, it's like he definitely is the. I mean, I always like. There's times that I'll try to talk him down off of a ledge of like something some idea he's got. I'm like, no, don't try that. But at the same time, it's so much fun because it's like there's so much passion and so much. I can't wait to do it. I can't wait to be out here. And it's kind of funny is I'll take a second about this it's kind of why I can relate to it. People don't realize a lot of times in my world, it's like I was thrown out on the shop floor as a little kid into this world. And sometimes I don't, it's harder to get really excited about certain things. But sometimes then you talk to someone like Nick and you're like, it's all revitalized. It's like, oh my God, this is fun. And, to take someone like Nick who's worked, he spends every dollar he has, he's PB&Js. I mean, this guy, there's a time when he's messaged me and he's like, hey, I'm a little tight, this, that, and the other. I'm like, I don't care. Here's your stuff. Get to the track. Do what you got to do, because keep him going. Because I've never found anybody. I can just tell you this. As a business owner, I can honestly say you're never going to find a more motivated person than that guy. So, I definitely think he earns his way. I definitely enjoy watching it. I'm glad he earned it. And I was pretty sure actually after looking at some data and talking to him when he was out at World Cup, if that motor had anything left in it, considering how much he wasn't really pushing it, I knew this thing has some serious capabilities to go a lot further. So
yeah, it was pretty cool. I think one of the funnier videos that I watched with him was talking about missing shift lights, and then he literally put like one of those light bar lights on his dash, and he's going down the track, and you can see the whole interior just light right up, and he's like, "I couldn't miss the shift light now." But anyways, we're gonna have him on the podcast.
I got a shift so I can see.
Yeah, yeah, exactly. So congrats to him. That's pretty awesome, and he's got a single 11-inch in that too.
Yep. Yeah, he runs. Yeah, he runs the same one you got actually.
Yeah. Okay, here's another. This one's just for me again. So on my car, I ran into the situation before where the track prep isn't great. I've got no base in the clutch. You know, I've got like a quarter turn in it, but I got quite a bit of counterweight for the drive and for the top end of the track. So I just lowered, like my best run so far. I was in the staging at where's the Gator Nationals at? Anyways, down in Florida, and people are coming back, and it's like 3:00 in the afternoon. I hadn't made a pass yet. I don't know how many passes I'm going to get, and people are coming back, and all the stick guys are spinning, and so I had the ability to lower my launch RPM, and I was at 41, and then I was at 39, and I think I launched at like 38, and did an okay 60 foot, nothing, didn't knock it out of the park, but then I went 877 at 165. So in a situation like that, cranking up the boost a bit and leaving at a higher RPM, I guess that's just going to blow the tires off, right? That's where I would end up. So you pretty much gotta back the RPM off, probably keep the boost where it's at, let the clutch do its job, slip until it locks up, and that's
and a lot of times it's the same thing we get into is you're always racing a racetrack. You know, a lot of guys always go, well, he slowed down. I mean, how often in this world, anything from drag and drives to H pattern to whatever you want to look at it, very, very rarely are we comparing apples to apples. Everything from the rules change from one year to the next to the conditions are so much different from what racetracks you might be at. So it's never apples to apples. And so, you know, you got to look at it that way. But when you're in that, you got to race the racetrack. And that being said, you know, the other thing to always look at in those types of scenarios is what load can you put on the clutch? So what I mean by that is if I can, let's say I've got a good double adjustable shock on the back, and let's just say I could move 30, 40 pounds from the nose and put it on the rear, or I could soften my clutch, my compression down a little bit, stiffen the rebound a little bit to keep the back end buried a little longer. If I can do that, I can launch at a lower RPM, any of those things, that's going to transmit more load to the engine, more load to the driveline, which obviously is the clutch. The more load it sees, the more clutch you've got to put in. So that would be where if I get into somebody that says, hey, I'm down to very little counterweight, very little base, and I'm still not slipping, maybe they're over clutched, or maybe they could be a situation where they tell me how much gear ratio they got, and I'm like, well, good Lord, you're running 40 points more gear ratio than what you need. Or maybe the back end of the car is really, really stiff and it won't squat or it won't transition weight or whatever the reason may be, but there's no load getting transmitted back up to the clutch. So if you get on a bad track, if you can find ways to add the load to the drive line, to the clutch, that's going to help you because that's just going to open your window back up. I mean, optimally speaking, you always want to launch at the higher RPM for especially when you're in bad air, because I hate to say it, most of the time you come with bad tracks, come with bad air, because usually that means it's hot, means it's greasy, means it's humid, etc. Those usually kind of go hand in hand. So usually if you can find a way to keep the power, but put the bite into the car, to kind of put a bigger load on it, that'll help you. So
no, makes total sense. Go ahead, Bill.
So let me ask, this is actually an audience question. I think it kind of goes with this one. And this is actually a question from Jonathan Atkins. Has your opinions and hatred of radials changed at all now that all the quickest and fastest H pattern cars are running radials? And to add to that, you've talked a lot about wheel speed, but when a guy switches to a radial, you can't have any of that. It's got to just be a dead hook, and all that slip has to happen in the clutch. So talk about that a little bit.
it's kind of a misconception. And what it boils down to is to answer Jonathan's question is kind of funny. And I would tell him this is when everybody kind of sometimes I think thinks me of privilege of some of the stuff because of my pro stock background and so on. But it's kind of funny, it's Bob Glidden preached something to me. I never forget when I was a little kid. I heard this all the time. As long as you copy the guy in first, you'll always be in second. And that transmits into something else. It's not that I have necessarily a hatred for radials. It's more of a situation where let me throw it at this way. Does everybody here remember several years ago when everybody said there wasn't such thing as a radial with a T56 going sevens, and Minion had been doing it for 2 years and just hiding his time slips? I mean, that's the funnier part, right? I knew it. I'd seen him. I knew what was out there. And I mean, the funniest thing was when Yandro, came to me, we talked about it. I mean, it was a fun project. I mean, yeah, you can do it. And I was like, no, you can run a hell of a lot faster. How much horsepower do you have? How much money do you want to spend doing something? And it's kind of like for the longest time, if you go back, I think that's my funny thing about history is some of the stuff is populated a little bit more now than what it was 20 years ago, meaning we have all this mass media, we have all social media, we have all these things. But what's funny is back, say in the early 2000s, everybody went to the 28-10-5, and Dr. Jamie Meyer, who everybody probably knows, was head of, PRI and SEMA, well, PRI now, GM's, main guy for a long time. Jamie always used to be the announcer and called it the 10.5-inch tire freak show. Everybody thought, good Lord, these guys are going sixes on a 28-10-5. Are you nuts? And, so the point I make with it is it's everybody, at one point it was impossible, kind of like when I ran, at 33-10-5, but nobody could, run 697 nose naturally aspirated until I did it. Then it was doable. And that's part of the same thing. So radials kind of could come along, and you look at no prep racing, you look at, street racing, you look at whatever, and it's all different ways to enhance the, what's the right way to say it? It's basically kind of upping the circus show of us racers, meaning it's harder. It ups the challenge. It adds the next ring of fire is the best way to put it. Okay. So, it turns it now that's where me and no prep, that's one of those things I tell a lot of people. I'm like, I'm not saying don't do it at all, but I'm saying be smart about it when you do it. Because, you do run into certain situations. Back to the question at hand. No, I've seen times where sometimes somebody switches to something, and I don't think that in our current world, there's anybody out there who is really what I would say put a 100% dedicated effort into basically a bias ply setup. I mean, in other words, it kind of comes down to a lot of people have started tuning off of extension, and you hear the word anti-squat a lot. And you stop and look at it, and there's other ways to skin that cat. So I look at it and go, I know that, let's say I can 60-foot 330 a car better on a slick than I can on a radial. What's the, in my opinion, and this is just looking at it, what's the biggest thing that we gain? Was growth is the biggest thing. You look at the two tires, if you really want to, this is performance, not stability, not safety, nothing along those lines. You look at it, they'll say, well, it's weight, it's growth, it's this, that, and the other. So I look at it more as not a hatred of it. It's not it at all. Obviously, I've got a lot of customers, running radials, and I help them all the time. There just gets to be a point in which I'll say, don't give up on it, because here's my question that I would ask in return. Is there anybody out there that could run a slick and run faster? Or is it just nobody's really trying that? Because what ends up happening is 3 years ago, nobody thought a radial was possible to do it either. And so I guess what I'm saying is I look at a lot of my customers. I've got a lot of really, really good customers. I have really good chassis, really good equipment, but they're still not, let's just say, some of their suspension options still aren't there in order to take advantage of everything. In other words, if I had a car that could compress, could rebound, do everything just like a pro car can do. Because a lot of people don't realize with us, and I'll explain this for 1 second. Let's say a pro car, we compress and we rebound and we compress again. Okay. So a lot of people don't understand that when we compress, and you see a pro car transition the weight and the back end comes down and it puts that load up on my drive line. Now, all of a sudden, that's a consistency. I can use that wheel speed to really get after it. I can have that slippage because somewhere there's going to be an inefficiency. I mean, the absolute perfect run would be able to throw every last bit of horsepower you can throw at it at every given time. But let's face it, that's not realistic. That's a perfect world. So somewhere we have to have an inefficiency. Where that inefficiency comes, let's say in a pro car, it's through the slippage of the clutch and a slight slippage in the tire. So in other words, if I compress and I put all that load back here, I can throw that much more power at it earlier. So if I can 60 foot, if I can 330 better on average. But now here's the question. Everybody says, but you lose it after that number. After, let's just say 330, I'm losing it. What if you didn't lose it? What if you could calculate for the growth of the tire? What if you could handle the stability? What if all of a sudden, like our stuff, it goes up? Basically, we compress and we rebound, meaning the car comes back up to ride height, middle of second gear, let's just say. This is all hypothetical in this type of a scenario. Then as we get enough mile an hour, we're going down the track. We get about the 8th mile, the thing's going to start getting downforce. We start compressing. We start sucking the car to the racetrack. Why is every car other than something like this, let's just say a top fuel car, obviously really comparing an apple to a kumquat, but that thing is, let's say a funny car, that the front end of that funny car is trying to scrape the rubber off the racetrack going down the track. Why is that? Aerodynamics. Why do you think pro stock cars were put in the wind tunnels and we play with this stuff? We want to suck every last bit of air out from underneath that car that we can. We want to make that thing a bullet. Well, the point of it comes back down to, though, is you have tire growth. The bias ply is a downside, especially small tire stuff. And this gets into something else because you also get into weight of vehicles. You get in some others. There's some other factors. So the radial has actually opened up a lot of stuff, but I don't think still this day it's the end all be all. And what I mean by that, though, is in order to be fast with the slick, you have to, and I've had a lot of my customers come to me and say they don't like the way, especially these fast guys on a slick, they don't like the way that the slick feels on the top end because it's going to walk on them. Okay. And the reason, though, is I've had a lot of them do it, they're tuning off of what they call extension. So they're going down through there and the back end of the car is kind of raised up. And so what ends up happening with that is your shock is basically kind of, for lack of better words, it's rock solid. It's hard. What's the softest part of your suspension left at that point? It's the sidewall of the tire. Yeah. So you're doing this. If that shock was not all locked out and it was sucked down and got all the air out underneath of it and it's moving, now your suspension still can work. So that's the problem that we're talking about is it's not that one is always better than the other. It's that they have to be tuned differently. And there's really not anybody that's really tuning a stick shift setup with a slick that is, for lack of a better way of putting it, really tuning it that way, if that makes sense.
Completely optimized.
The other thing, though, right, and it's just, it hasn't been optimized. That's the point. But here's the reasons I tell most of my customers, and one that everybody know, which he's got out of it now, be Wes Evans. He played with both, and the thing that I told him, I would tell everybody, you can tune a radial and a slick, and there's some things that we can do to keep them fairly close. It doesn't have to be, it's not like we have to change everything all over. Obviously, I've got plenty of customers, doing a lot of stuff with radial stuff. And it's not saying that, it's saying that there is some other ways to do it, but it's not a direct replacement. I'm not saying go take and I think that's something that maybe is a perceptual difference for me, is going to be that a lot of people in this type of an environment, and maybe I'm used to it differently, is they want to say this part works better than that part. And that's not the case. That's not what I'm saying. Meaning, in other words, it's not okay, I bolted this guy's rear end in my car and I went faster. I bolted this guy's valve cover on and I went faster. That's not the case. It has to do with all the parts have to be. So it'd be kind of like if someone wanted to compare my clutch to another clutch. Okay, but is it the same horsepower? Is it the same weight? Is it the same transmission? It's because all these parts have to work together. So when I look at something like a tire scenario, if a guy comes out, and this isn't, by the way, Viking, if you're listening, not bashing on you, but if somebody tells me, hey, I've got a Viking shock on it that's a very basic deal, and I'm trying to do this, this, and this guy over here says, I have a double adjustable or a triple adjustable piggyback canister shock from Penske that's been valved for my setup, and I got shock travel sensors, different ballgame. So then we get into the H pattern thing, and it just turns into a thing where obviously I love all my customers and everybody doing it, but ultimately speaking, it's kind of getting to that point where it's like the bar is going to continue to get raised. And it's going to be who wants to do what, who wants to spend how much. At what point where is the cutoff point? And so that turns into that. But no, I don't think, I'm not. What the funny thing is everybody thinks, a lot of them, I think they think I'm against a radial. Not at all, because there's a lot of tracks, I'll tell you right now, it's probably better to have the damn thing on in the situation you're in. And if you get out these guys that they think a good racetrack is solid VHT, then yeah, that's probably not a bad idea.
That was going to be,
that's the one thing.
That was going to be my comment, is that, when I went to Sick Week in Florida, I mean, those tracks, they were all flypaper tracks. Like, they were prepped for radials. They first talked about keeping one for slicks and one for radials, and but pretty much all of us with slicks were, wadding the tire up, and like it was sticky down there. So I think that's where you were just going is you might as well have a radial if they're prepping for a radial.
Well, and something I always tell people, this is kind of fun when I get into like doing our seminar stuff. I'll ask guys, I'll have a class of 20 people and say, hey, everybody, can somebody describe to me the idea of a great racetrack? Like describe the conditions. You're walking out on the racetrack. What is it? Every time somebody's always going to tell me, oh, when it sucks your shoe off, when there's glue. No, whoa. No, that's not, no. And I'll tell them like the best track prep, and I'll tell you right now, every pro stock, pro mod people that come from the last 20 years who have basically got to do some of this stuff, everybody will tell you the coolest stuff we ever had. When I say we were spoiled, that's an understatement. Was when we had the traction twins, and Cale and Cody, Chris, and their dad Larry, from Vandermeer doing all our stuff. You walk out on the racetrack, and they would scrape. They'd be out there on Tuesday before our race, scraping that son of a gun all the way, literally, putting down all brand new rubber. And you walked on it, there wasn't a dang bit of VHT until 100 feet, and it was like, but we could throw everything we could throw at it, and we couldn't, knock the tire off. And we were, like I say, we were spoiled. But you get back to a situation where when you get racetracks that tune with just glue, what happens with a slick, what people don't understand, you take your foot out there and you walk on that thing, that's not the same as your tire that's got all that torque behind it. Once your tire turns that loose, instead of it being a stick, it's now slip and slide. And so that's the problem that you get. And so when you how do you tune a radial? Well, a radial, they drive out onto it. You more wheel speed, kind of like an automatic, right? So when you do it that way, that's a safe way. Well, you can tune your slick car to do the same thing, but it turns into a thing where you've lost that advantage that slick presents because you can't use that wheel speed. So, that's that's going back. That's why I say, I'm not saying that one is better than the other. I'm saying if I could have the best shocks, I could have 4-link, I could have everything. Basically, kind of like giving me the pick them, and I have an endless budget and I can build whatever I want, I might go at it a little bit different. But at the same time, if you're out there and you're racing in different things and you're doing these different shootouts and you're on different good tracks, bad tracks, they both have their place. And so it's not that one's necessarily the cat's meow over the other. It's just each one has its difference. And I will say that a lot of my guys, I do want to make this preface there. A lot of my guys who are kind of come in the 800, 1200 horsepower street strip drag type car, and they're heavier, 3,000 to 35, maybe even 4,000. They're heavier. They're not a real lightweight car. Generally speaking, the slick almost always just works better on those. And it just has to do with how much you're controlling. I mean, obviously there's things you can do, but if they're limited on gear ratio, what they can run, like a transmission, they're not running a Liberty. They're not running a Linko. We're kind of, G-force. We're not set. Those situations, it just has to do with it's a little more forgiving. They're going to be more consistent. They're going to be happier, and I can do a little more with it. When you start getting into ultimate power ranges where we're just more power than we could ever use, that's where I kind of look at my old Outlaw 10.5 car. That thing was under 1,500 horsepower, weighed 2,900 pounds, and, I could run 697 O's naturally aspirated with it. Granted, I had a 5-speed clutchless Liberty in it, but you're 60 foot and 106s, and, there's a big difference. And keep in mind, it's bad thinking I'm closing in on 20 years ago. The point I'm making with it is, you look at it today and you go from 1,500 horsepower to 2,500 horsepower or 3,000 horsepower. So what, you got that little tire, and you only 60 foot, 5, 6, maybe let's just say you 115, 116. Okay, great. But now you've got almost twice the horsepower. You ought to be running out the back end, because basically that 60 foot, you're going to pick up that 10th pretty quick. So it's really, at that point, it's a rolling number, if that makes sense. It's not so much because in stick shift cars, let's face it, where you ever go to pro stock pits, I'll tell you right now, the number one most impressive thing is who's 60 footing. Yeah, it matters. The qualifying sheet matters, but the guy that's tuning the car, the guy that's the crew chief you're looking at, is the guy you look on the sheet and has that low 60 foot for the event. And they do it every time. So that's where you're working the suspension, you're working the transmission, you're working everything to get it. So
Cale, let me ask you a question then. Speaking of the whole launching and 60 footing, is there an order of operations for stick car launch tuning? Like, which knobs do you set and forget, and which ones do you change all the time? And let's try to keep this to cars like Rich and mine where we can't change gear
Okay.
ratios, all that kind of stuff. Let's
Right.
keep it to that.
I mean, realistically, the only thing, I mean, you can get a little bit lost, but I will say a lot of my customers, once they know their cars a little bit better, um, playing with your compression, your rebound, moving some weight, moving some tire pressure, those are very good things. Obviously, counterweight, base, and launch RPM or clutch world. Um, but if you find that, let's just say the track's a little snotty, you don't want to really have to lower the launch RPM as much as you're doing. Maybe in that scenario, and obviously different shock is going to be different. But let's just say I could take a 5-click, adjustment and take compression out. And let's say I was looking on a graph and I could let it compress an extra quarter of an inch. That's quite a bit. So if you were looking at it and let's say the back end's compressing, well, you got to look at it. If that quarter inch, how much weight does that transfer? You ever get bored? This is as simple as going out and getting you some scales and going out with a floor jack in your shop and jack your car up and go a quarter inch at a time and see how much weight goes to the back end. You'll be surprised how much goes back there. And as every little bit goes back there, that's that much more weight, and it takes that much more horsepower, torque, leverage to do the job. So that's something to always think about. You can move weight. If you take 20, 30 pounds in a car that weighs 3,500 pounds, doesn't sound like a lot. 30 or 40 pounds can make a hell of a difference. And the first, you get to look at, am I putting it right over the rear end, or am I putting it over there by the bumper where I've got leverage? Or am I taking it off the very front of the car and putting it at the back, which would be the same as adding like 90 pounds to the back of it? There's some things to think about. Tire pressure is something I try to get once. If you have a combination that's set up right, that you're close, tire pressure really don't want to be the thing that you're using for a Band-Aid. Meaning, if you're out there and you're trying to get a lot of wheel speed and you're going from 10 pounds to 14 to 16, stuff like that, like big changes, that means you got something else wrong somewhere else. I mean, I'm not going to say that you won't make a half pound change if a really good track to a really good really bad track that's not there. But realistically, tire pressure is something that I prefer to keep consistent. Like, it's just kind of is what it is. I'm not saying we won't play a little, but for the most part, that's not something once we get close, it's not something you should be messing with all the time. Shock adjustments depends on how comfortable you get. Once you kind of have got and that's the next thing. The problem with shock adjustments, if you're not running a shock travel sensor to look at the information, that can you got to be careful, because keep notes, keep all your notes. And then also keep in mind, if you're a drag and drive deal, that car gets all of its beating on that shock going up and down the road, not at the drag strip. Same thing with guys in race cars that haul them to the racetrack. Guess what? It gets beat up in and on the trailer, not going down the racetrack. So what you do at the beginning of a trip and what it does in the middle of the trip might change because of, basically how worn they're getting, how things are happening. So, be careful not to get lost is the best way to put it. I mean, don't be a tinkerer to the point in which you get lost. Keep good notes. But, I would definitely say that anything in shock compression rebound, that's going to control, how much load you get. Same thing with weight distribution. And any of that stuff is going to control load on the clutch. So that's going to allow you to make changes there. So
That's awesome. Let's see what else we got here. What do you got, Rich?
This is a good question. So the question actually says, how often would you send in your clutch for rebuild? I would flip it around and go, what should you look at that would trigger you to say, time for my clutch to go see Cale?
It's kind of funny. I get both types of customers. Obviously, we got the guys that are, let's say NHRA guys or, divisional guys or whatever you want to say, and they're very, very, very meticulous. They're going to send them in, obviously, in the off season because they're going to start the season. They don't want a lot of racers, almost everybody. They don't really want to start the season not with something fresh in the car. The time to do it is obviously in the beginning of the season, so that way you're not stuck out there in July, August, September, going, oh crap, I need a little bit more. At the same time, I try to tell my guys if they don't need it, it's not. If it's not necessary, it's not necessary. I got a lot of my guys around locally that run our Ozark Super Shifters. And some of them they'll leave them in for a couple years at a hit because they're only running 8 races a year, and most of these guys are running mid fives, let's say. But the big thing you got to look at when it comes to longevity, and let's look at drag and drive guys very specifically. you don't want to be out there with a disc that is, let's say most of my stuff is going to come out. So you're going to get a disc that's going to start off around 380 thousandths. If we didn't replace the heat shields, let's say it's come back or it's brand new, whatever, the heat shields aren't going to be your thing. You're probably going to be having to watch, because if I have sent it back out, we're going to know that it was okay to go for another round. But the disc is still going to wear. As that disc wears, if you go out there and that thing's at 320 thousandths and you're getting ready to start the year off and you know that you wore 60 thousandths off last year, probably ought to send it back here in the fall, not wait till the spring, because you got about 2 months on it and it's coming back. Most guys don't want to be down, and I get a kick out of them. They're like, well, I don't want to be down, or they'll send me a text message and, hey, I hope to have that back next week. I'm sending it to you today.
You know what they need? They need to buy 2 clutches is what they need to do.
Right. And it turns into a situation where generally we can turn them out pretty quick, but the problem also comes back down to is there's only so many hours in the day. And if they're going to wait, and that's fine. A lot of my guys, they'll have 2 of them. And sad thing is most of them, they don't even end up using the second one. It's pretty rare. And, it is what it is. But, obviously you're doing drag and drive, anything can happen. Hell, just an oops on a tuning thing and you leg it out a little too far, or something, hell, a bearing stays a little too close to the levers one time or something. We know how that happens. And, so then the next thing you know is like, oops, and having that spare clutch is the difference. That's one thing about why we do things the way we do them. I don't want people to have 2 of them. I want them to know they got thick heat shields, they got segments, they've got they have durability, that they're not going to have to be that way. But at the same time, it's a clutch. Like it, lump it, or otherwise, no matter how great we design it, no matter what we do, it's still a wearable item, and it has to be serviced just like an engine. No matter how fancy your engine builder is, no matter how many awards they won, it doesn't mean that the engine will last forever. It's still wearable parts. So ultimately speaking, it's kind of a thing where I usually tell everybody, if your disc, depends on what you're going to do. If you don't mind being down for a month, that's your call. If your disc is 3/4 away, from, through its thickness, and by the way, I will throw this out there. There's certain people out there, manufacturers will sell you a new centered iron disc that's 280 thousandths thick. I don't do that. To me, that's almost worn out before we ever use it. So it's just personal preference. I don't do that. The only time we've ever gotten into those situations that we will use one is when I've got somebody in a very restrictive height. And this is also, I will say, let's say 10-inch, 11-inch, bigger stuff, not little small diameter circle track or special, like those type things. But basically, when I get somebody, the clutch is down to, 280 thousandths, we're basically at the point where it needs to come out. It's worn 100 thousandths off of it. It's time to go bye-bye. So if you're pulling your clutch out and that thing's down around, 300, 320, 320 will go a little longer, but if you're 300, it's probably time to start making the trip back this way. So
yeah, my friend Brent Stevens, was trying to do his first drag and drive event, and then he thought he blew his motor up or something, but it was just the disc, and it's like, yeah, you might have waited a little long on that one before you maybe should have sent it out a little early. So he listens to this all the time, so he'll get a chuckle out of that. But yeah, it was missing chunks. So,
I do want to bring up a point there that might be smart. We go off the deep end on rebuild stuff. Like, obviously, it's what we do. So, it's kind of one of those things where we want to fixture things, make sure things within very, very little bit of tolerance. Look at different things. I had one of my customers, it was kind of funny. We had a pressure ring come in from a next gen, and it'd been out there a while. He's one of the faster H pattern guys, and it came in, and it was done. It had been rebuilt probably 4 times, and he's, RPM. And it had a taper to it. So, it's time for a pressure ring. No big deal. But at the same time, the reason I bring this up is that's the big thing. It's just making something flat on a surface grinder. Obviously, about anybody can do it. Doing everything completely right and making it just perfect. There's a few ticks to it. But the thing I will also say is something to bring up. A lot of people don't need to get too worried about, might be the right way to say it. But you'll get discs where, unless it's big in bracket racing. But if you ever get into the fall, spring can do it too. Fall just seems to be more notorious for it. But these guys go out and they pull their clutch out at the end of the year, and the disc is missing chunks off the corners or out the edges. And they're looking at it and they're really upset with it and this, that, and the other. Here's the problem that happens with that. Keep in mind. Now, don't get me wrong. the more heat you build in them, the worse. But a lot of these guys, they go out and let's say they're, I don't want to say hot lapping them, but they're making a run like, in the fall, and they make a run, 15 minutes later, run, 15 minutes later, run. They do that 2 or 3, 4 times, put the car in and on the trailer, and they go home. The clutch does not get, released. So the thing goes home, and let's say it's 55 degrees outside. It's not 75, 80, 90 like the rest of the year. It's cool. But they set that thing on the trailer, and then they go home, they light the car, push clutch pedal down, and now what's happened is that flywheel, that pressure ring, that disc were really hot, and they shut the car off, all smashed together, and that disc, basically the graphite, the different metals, the different powder stuff in it, basically turned to hot goo, and they seep to that heat shield. Now, when they push the clutch pedal down, it just rips it off. And so a lot of times I'll tell guys, when you start getting into those situations, even, different type, if you think it's anything you're worried about, as the car's cooling down, take a minute, push clutch pedal in and out a couple times. I've even got some of my guys who started rigging it up where they just got a thing that holds their clutch pedal, down and open for a while. That's another way to do it. So, if you do that, it is a way to save it. So.
Perfect intro. It's like you read the questions. Hey, Bill.
Yeah, because I was just going to ask him this. You want to ask it, Rich?
No, go ahead.
Okay, when cooling the clutch between passes, is there a specific temperature you like to see before making another pass? And I will say, I have an infrared sensor in my bell housing because I have noticed the performance of the centered iron clutch gets a little bit touchy when the temperature gets pretty hot. But is there a temperature that you'd like to see? I can tell you what I like to see, but I want to hear it from you first.
There's a variation in this, and here's what I'll throw out at you. If you look at high speed, low speed friction dyno information, and I've done some stuff with what I call a shear test, and it boils down to there's a temperature variation. So when you're looking at friction coefficient, testing different materials, like we were comparing 5191, which most people explain, this is Ray Bestis terminology, by the way. It's just been around so long, it's what everybody uses in the industry standard. We have other compounds, but it's what kind of people refer to. A 5135 would be the highest friction coefficient, and that's what almost all you guys run. It's what you run, it's what Rich runs, it's most of my guys run. 5191 is on the other end of the spectrum. It's about half the friction coefficient of a 5135. It's what we run in a Pro Stock Pro Mod top fuel type car because we use more applied pressure rather than friction coefficient. So that all being said, the different materials have a tendency to gain temperature more quickly than the other ones. The 5135, we're just going to stay with it because getting off the deep end on the rest of the stuff, most people are never going to need to know here. So almost everybody's going to use a 5135. 5135, I've gone sometimes and had people compound my stuff differently. That's where most people have found out over the years. Most people tell you, I get a little off the deep end with this, and they've known from what disc they get, and I know Bill's experienced it. And a 5135 is like, I don't want my stuff to gain a lot of temperature or gain a lot of friction coefficient at a low temperature, because the more heat you get, the hotter it gets, the more grabby it gets. So if I've got one that, let's just say at 150 degrees, starts getting more friction coefficient, because it gets pretty quick. Like you can gain 15, 20% on the old Ray Bestis, the old stuff back in the day. You could gain, say, 15%, 20% friction coefficient on a 10, 10.5, 11-inch style disc by 150, 160 degrees. That's quite a bit pretty early, okay? A lot of these guys are doing stuff like what you're doing. That clutch may be already at 120 degrees before you leave the starting line. So halfway through the run, she's really getting hot. If you didn't have a couple hours to cool that thing down, it may be hot. So I try to, anything we do tries to be a little higher in that temperature spectrum. So we want something closer up to 180, 200, 210 before we start seeing big gains. And that's just basically changing how it's made. That being said, I can tell you right now in our Pro Stock stuff, we don't, like, if we ever have to, I shouldn't even say Pro Stock, a Pro billet style clutch that we zero the ring height between runs. You don't really want to zero it until you get down around 100 degrees. And that 100 we take off of the center of the hub. So the hub and right around your input shaft, that's where we do it, because it's actually usually the place that holds the heat the longest. And so we try to get, if that's at about 100 degrees, otherwise what happens is we zero a stand, we go around the engine, we come back. By the time we get back, it's off 6,000s from where we set it. So that's the variance. I would say most of the time, optimally, you would want to be under 100 degrees would be where you'd want the clutch to get back down to. in that ballpark. You probably, if you're really getting down to it, like what you're talking about using infrared, also it's going to differ where you take the temperature. But if I'm taking it like where I'm talking about, generally speaking, because you obviously can't do the actual surface of the disc. That's, I mean, you could you could come in from the side, but that's just been the place that we've used to be the most consistent. But yeah, I mean, I would say you probably want the clutch disc itself. You could probably get away with, say, 110 or something, but 100 would probably be your optimal spot to be the most consistent or cooler.
Yeah, and I would say that infrared sensor on mine is probably shooting at the hat. And I've gotten a pretty good baseline of where I want to see it. But yeah, I would agree.
I'm guessing I would probably say you'd be a little cooler than that. I would say if you're looking at the hat, you could probably get it down, 85, 90?
Yeah, so really 130 is about where it likes to be. And that's typically what I see. But so what I see in the long drives is basically the clutch temp ends up being what the engine temp is after the long drives, because everything's getting to that same temp. So it's not unusual, especially in traffic and stuff, when it's getting hot, man, I'll see 210 degrees on that clutch and it's super grabby and it sucks. And I'm like, come on, let's just get in sixth gear and get down the road. But at the track, like I like to see about 130 degrees on that sensor. I
hadn't thought about it.
Yeah.
I hadn't thought about it, but yeah, I mean, here's the other thing. It's also going to depend on the application. Meaning, where you're tuning it, that may be better, but it may be a thing where if you ran it cooler, you could change some other things and that'd be your optimal zone. So it really just comes back to the real simple fact of consistency. It's one thing I go back to notes. It's the thing I go back to everything. That consistency is the biggest part of tuning a stick shift car. Make sure that everything you change, you don't change 10 things and wonder what made the change. So
yeah. So let me ask you one of these other questions here. How do you calculate the needed base pressure for a given engine, torque, disc, material, clutch diameter, all that stuff? So like for Rich's car, he's got a next gen with 6 levers. The 3 lever is probably not going to cut it. But how do you come up with these base, like when he calls you, you kind of tell him where to start. And from what I've heard, it's pretty close. So how do you come up with this? Is it just math or just experience or what?
It's a little bit of both. I will tell you it's probably 75% experience because, it's kind of like the problem is, let's say I go make a spreadsheet to tune this. I actually got asked one time, hey, why do you take all these tech phone calls? Why the hell don't you just make a spreadsheet, tell people how to tune these clutches? Yeah, I wish it was that easy. But it comes back down to the fact of, the problem comes into, let's say somebody, I mean, it can be as simple as what first gear ratio are we running? Where's the weight in the car? If one guy shifts at 6,000, the other guy shifts at 75, big difference. If the guy's running a stiff sidewall slick versus a radial, or a guy's running, I mean, one of the biggest things I get into is my bracket guys that they call up. They're like, yeah, I got me. It ain't that big a tire, but I got 600 horsepower and 2,800 pounds. What size tires on it? And then you hear 1432. And you're like, okay, take the tire off the thing and go half a second quicker. But the point I make into it is I have to take all that into account because how much load is the clutch going to see? I generally try to start most of my customers where I think they're going to, obviously it's all going to matter a little bit. Do they have any experience with an adjustable clutch? Are they data logging? If they're, what's our combination? But I try to, let's say most of them, I try to start them where they're a little on the heavy side, maybe launch them a little bit softer so that when they launch softer, it doesn't have the counterweight coming in. They drive into it. They're getting off the starting line. They're getting us good data. They're getting at least feedback, even if there's no data logger. And at that point, we can slowly take 3 grams off, take a half a turn off, make another run. But I don't like when guys are out there having, the old school, the old, I mean, not to throw any of the company names, but let's just say the old school of long style stuff. The old way was, put 8-9 turns of base in it. Don't worry about counterweight and take a half a turn out every run until you slip a little in high gear. No, please don't do that. And the thing is people always try to understand the difference between base and counterweight. It's like, is base just the starting line? No, it's all the time. It's just a tickle number, meaning, 3 turns of base might only give me 180, 200 pounds of pressure versus at 7,000 RPM, 6 grams will give me a lot more than that. Might give me double that. So, it's all a relative thing. So that's why you always got to look at it and calculate how much pressure am I getting at any given RPM. But no, it just like say it all goes back once again. This goes back to that consistency factor. It's all about doing the same thing twice. But If I can get them a little bit on the tight side and then slowly back them off, obviously most people would rather spin the tires a couple, 3 times than they would to, and every once in a while I do have that guy that, tells me, well, I couldn't feel it slipping. And they send it back and you're like, whoa, it does happen.
Seen that there was lava.
And I have one customer I'd like to give a shout out to because I really enjoy my phone conversations with him that left in second gear. And basically, I've never seen anybody actually cook my base stickers to brown, but that was pretty impressive. So he's been very fast and he learned that lesson. So yeah, he's good. But no names tonight. But,
it's funny. I've had the automatic guy say to me, "Have you tried leaving in second gear?" And I'm like, "No, I haven't." And I'm pretty sure it ain't gonna work.
Bad idea.
No, anytime somebody goes down that path with me, the thing I usually tell them is like, listen, it's like we have suspension options. And here's the thing: if you're having to leave in second gear, and let's face it, I don't know any, especially in the Tremec style world, it's like, if I have like a 180 something second gear, there is no torque multiplication factor here that your horsepower should ever be a point in which you should be able to leave with a 180 something. I don't care if you got a 600 rear gear, it should not be doing. No, don't do it. So
yeah.
Nice.
Just a quick question. It says, do you dyno every clutch you send out after rebuilding, or you have enough experience now that the builds are pretty similar? You have a good baseline.
Basically, at this point, there's no real reason. The dyno is really more of a learning tool. It's more of a developmental tool. And I mean, don't get me wrong. I'll have guys send me in, another, let's just say another make or brand clutch or whatever. Let's say, I've done some, the pro stock stuff, the smaller stuff, smaller inch things, this, that, and the other. And it's usually, if we're going into that, it's because we're just trying to design the lever more specific to their build, what they're trying to do. But there's not really a reason to do it. The only time that I've ever done that and gone out and done it is if I've had once in a while, we have a weird thing, like literally you'll get a clutch that you're like, it comes in and somebody will be like, man, this ain't, there's something, they have 2 of them. They're like, hey, this one's working great. There's something wrong. And you go through it and everything works and they go, no, there's still something wrong with it. We'll play with it. Generally speaking, that being said, when I say I've never found a problem that was with the clutch when that happens, it's usually always something else weird that they've done that they can't find. If the clutch will actuate properly, you don't have any kind of lever pin bind, anything like that, it kind of gets to a point where it's either right or it's wrong. If you have a problem in an adjustable clutch to which we're worried about it, like it's not doing what it's supposed to do, it's usually because a lever's hung up somewhere or there's something binding on a cover. It's usually you can articulate it, in a press and figure out what your problem is. So not really necessary. I mean, every once in a while I have a guy ask me to do it, but usually it's pretty much not necessary. So,
Rich, do we want to hit our TKO round? I can see where we're at on time here.
Yeah, we're 2 hours in. Did we how did we do on our customer questions?
I think we hit them pretty well.
We hit that one. Sure.
All right. So Cale, in case you didn't know, Tremec makes a 5-speed transmission called the TKO.
Heard about it, yeah.
Yeah. So we have 5 questions. This is our TKO round. Everybody gets the same questions. First gear. What is the first car you owned or modified?
1970 Mustang, grabber blue fastback, 351 Cleveland 4-speed. Still have it.
Nice.
Oh,
nice.
That's pretty awesome.
I'm a huge Cleveland motor fan, just so you know.
Hey, my dad obviously was, pro stock when Clevelands were pro stock.
Woo.
And so it was like, you got to learn how to build this Cleveland. And it's, we used to saw the ports off and we used to do this. And we used to do, I'm like, no, we're good. I'm 16. I don't need to die
yet. Okay. We're going to slam her into second gear here. What, in your opinion, has been the biggest technology change to move our sport forward?
Yeah, it depends on how far back we're talking. It's funny having my dad's going to turn 84 in like 3 days or 4 days, whatever. So I get to hear all of it. He tells me how they used to dodge potholes going down the racetrack in a pro car. But, he'll hear him and Animal Jim stories and whatever. But, honestly, I would actually say it's definitely data acquisition by far. But I mean, there's a lot of parts and technology as far as engine components and materials, things like that. But it's not just the data acquisition, it's really the ability and the teaching and the time that it is taken to interpret it. Because there's so many guys that have that information, but they don't really know what they're looking at. Like I'll get guys in the graph, that's tons of information that they missed a lot of it. There's a lot more there. So I really think that it's really the ability to interpret it, use it, and you start and look at all these different people that are in fuel injection stuff now. And I was telling you about earlier about my 698. I had a fast throttle, fast EFI box on it, XFI box, and actually I had the original one for the XFI even that piggybacked an MSD box to do the ignition. And I look at it and I'm thinking about what we do then to what we know now. And I think about everything from Fuel Tech to Motec to you just name them, Holly, I don't care, all these guys, and they all have good products, and it's because of what they've learned in development. That's where these guys have been able to, take the next step. So
awesome.
Let's palm shift this baby into third gear. If you could spend one day with someone, live or dead, who would it be, and what would you do?
Ooh,
we keep saying we need to prime you with these questions before this because that's a big one. Sorry we didn't do it, but there it is.
I honestly can probably say I'm a big history person, not even just racing stuff. Like I'm a little bit of a dork. I'm going way back. However, to keep it car related, and I think this person would still, no matter what, how much time I had to think, would still be in my top three. Honestly, it would probably be Carroll Shelby, because after just getting to meet him and hang out with him a few times, having sponsorship deals, some different things. One, he was just slight bit crazy, but in a very good way. A little cutthroat, and the fact of the things, the way he did things, just everything from I never forget. There's Vince out there is one of their VPs, and I never forget listening to one of his stories about how Carroll put him in the car, and it was not long before Carroll passed, and he gave him out there in the road course out at Vegas, and basically just scared to death. He knew he couldn't see where the hell he was going, but close enough. And I'm like, no, I kind of relate. Like I totally get it. So yeah, I think that'd be it.
So
that's an awesome answer.
If it wasn't car related, would you change that answer?
There's a lot of, possibly, only because, one of the things that I believe when it comes to history, and I think that may be sometimes what perceived as arrogance, smugness, and cockiness in the racing world, is just because I grew up the way I did. I've heard so much stuff. I've seen so many things that most people are 18, 19, 20 years old before they really start processing. I was getting it shoved down my throat at a very young age. And so I've always believed it's very important to learn from history, like learn the mistakes of the past. I think about people that think things are a technological advance and it's so impressive. And sometimes it's like, well, did you know about this? And they're like, oh, I had no idea, So I believe in that. So I think, if I had to go back, really, really, really go back, it's one of those things where obviously from my perspective, it's people that were ahead of their time. I've always been fascinated by people that think outside the box, that come up with things. So, it'd probably actually, not to sound cheesy and dorky, but, I'd probably be back all the way back to like a Leonardo da Vinci. It's like somebody that really at the time was considered almost nuts, but it's because they're thinking outside the box. And that's just kind of how I always do. So.
Awesome. Okay. Question number 4. Now this one might, be interesting. What influences you to build your cars? And I don't know if you're still messing with your Mustang and because of your accident, or you still obviously can make changes.
Yeah. Well, here's how I would probably answer that question, is like a lot of people don't, I think a lot of my customers realize, I like to live vicariously through a lot of my customers because I enjoy teaching. So that's why I think a lot of them realize that, yeah, I get a little upset whenever I feel like they don't listen. It's like, no, I'm telling you, I know this. Like I've learned this lesson. Please don't learn it the hard way. Let me show you. At the same time, it's a thing where I enjoy it. It's the same thing why, I was asked why I didn't kind of get back into pro stock stuff a little sooner, and when Derek approached me, with that stuff, it was kind of like perfect situation, because it was nice because I've got these, these brothers that are 30, 31 years old that are, they have family history, they have knowledge, but they haven't done it at that level. They're open minds, they're blank slate. It's fun to do. So, for me, what kind of influences me, honestly, is I've learned something is nobody cares. Everybody's worried about, okay, as soon as you win this race today, I don't care if it's the big go at Indy. Nobody cares that you won it. I'm gonna tell you now, half the time people can't even tell you who won it last year. The only thing they care about is who's going to win next weekend. That's all that matters. I mean, and especially as Americans, let alone world pop civilization, kind of short-term memory. So, I look at it as it's something that I like tinkering with, something I can learn from, something I can make myself better, a way to challenge. And the best way to put it, I was always that guy. Maybe it's stupid, but I always rather be the small fish in the big pond because at least I'm getting challenged up. Like running pro stock when I had an engine, a small crew, family stuff, busting our ever-loving butts to be there, and spent eating PB&Js to go, and knowing that there's guys over there that got 4 motors under the counter in the trailer, and I'm in the finals or semifinals, it felt really damn good knowing that it was me having to work harder to get it. I like that challenge. Same reasons why I built an Outlaw 10.5 car naturally aspirated when it was a power adder class. Why? Because I thought I could do it. It's just that's, just kind of how I'm wired, but it's more of a self-challenge every time, no matter what it is. So
nice. Awesome.
Nice. All right, so into our first overdrive question. 5th, what, in your opinion, is the secret to stick shift racing? Drag racing, of course.
Really? The right way to say this is consistency and not getting out of your own lane. Like I said earlier, that, the quote of, as long as you copy the guy in first, you'll always be in second. There's a point in which be smart about what you're learning and try to completely learn it. Try not to just go off of other people. Every combination is different. And the example that I'll give of this is I've seen 2 pro stock cars that I've tuned. I've seen stuff built side by side on the same jig, like everything as clone 2 cars as you can clone them. They're not the same. I don't care what you do. They're not the same. You got to give them what they want. And, is what works for this guy doesn't mean it'll work for that guy. And it's kind of like if everybody's doing it this way and it can't be done another way, doesn't mean that I'm saying you got to go try it another way. Don't be afraid to try something. Don't be afraid to work a little harder. And when it comes to stick shift racing, to do it good, you need to understand it and be willing to turn the screws. Because if you're not to be a smart ass with this, but that's what automatics are for. It turns into a situation where that, you're taking a challenge out of it. So, challenge yourself.
Awesome. Perfect. Okay. We got a T56 overdrive question for you. What advice would you give to somebody getting into this sport? Stick shift racing.
Do it right the first time. 100%. Don't buy once, try once, get the right information. If it takes a little longer to build the car, you go, by God, I need this, and I'm going to be out by April, and it's March, but it's going to take you 3 or 4 months to get the parts that you need, or a year to get you the parts you need. Do it once. Don't break stuff. Don't go out and then be upset with the products that you've gotten because you got them to get you by. Do it right the first time, because if you do it right the first time, it's kind of like when guys will tell me, hey, I'm building this motor and it's going to make 1,600 horsepower, but I've got this other one that only makes 800 horsepower, and I'm going to put it in to get the car lined out. No, you're not, because that 800 horsepower motor doesn't do anything the same. The clutch is wrong, the gear shit, everything's wrong. So, basically, and also keep in mind, sometimes saving money costs you money. Careful.
Oh, yeah.
Look at that.
Oh, yeah.
Yes. All right, Cale. Well, we really, really appreciate your time tonight. We want to have a huge shout out and thank you to Stick Shift Nation for hosting this podcast. You can find Clutch Burners podcast on 10 different platforms. And if you'd like to see this podcast continue to grow, head over to stickracing.com, grab a Stick Shift Nation shirt, hat, or sticker, and Clutch Burner shirts are on there as well. So if you want a badass shirt that, all the girls are going to love, then you need a Clutch Burner shirt.
Yeah, thanks for answering all our questions, Cale. That was awesome. The detail was fantastic. I think the people listening will appreciate that. So
definitely.
Really appreciate it.
So just hang on 1 second. We'll call it here. So goodbye.
Thanks for listening, everyone.